Hello everyone, continuing with KCET PYQ series. This time I'll be doing three-dimensional geometry from 2014 to 2025. For all our new viewers, I've completed 4 chapters till now of this series, 1984 to 2025. I completed differentiation chapter, application of derivatives, definite integration and application of integrals. These 4 chapters have been completed from 1984 till 2025. Okay, and this chapter is from 2014 to 2025, only 12 years PYQs, because earlier to 2014 we didn't have this for CET exams. Okay, so only 2014 to 2025, three-dimensional geometry. Okay, it includes both of first PU and second PU concepts. Okay, of course in three-dimensional geometry second PU we have got only lines. I'll be doing planes also, because planes is required for other competitive exams like NDA. Of course for JEE mains it is deleted, but for JEE advanced it is required, so it will be useful here and there if you write some other one or the other competitive exams. So I'll be doing lines as well as planes of second PU, and first PU also I'll be doing all the topics of three-dimensional geometry, all the concepts of three-dimensional geometry like distance formula, section formula, centroid, all those things. Whichever is asked, I'll be covering all the questions from 2014 to 2025, okay, of this chapter. We'll see the number of questions appeared from different years of this chapter, three-dimensional geometry, okay. In 2014, they asked 4 questions, 2015, 2 questions, 2016, 2 questions, 17, 18, 19, each 4 questions, 2020 also 4 questions, 2021, 5 questions, 2022, 4 questions, 2023, 5 questions, 2024, 5 questions, 2025, 3 questions. So altogether I have 46 questions, okay, of three-dimensional geometry from 2014 to 2025. I'll be doing concept wise, also explaining the concepts along with solving the previous year questions of this chapter. That's the most beneficiary thing of this. Along with concepts, I'm discussing the questions, okay. So we'll discuss the questions one by one now. I'll begin with the questions now. The concept also, we'll see. The introduction part, the coordinates of any point in space is given by P, x, y, z. The ordered triplet we call, correct? Any point on x-axis is of the form x, 0, 0. Any point on the y-axis will take the form 0, y, 0. Any point on z-axis will take the form 0, 0, z. And any point in the xy plane will take the form x, y, 0. XY plane means z coordinate is 0. YZ plane means x coordinate is 0. If you take XZ plane, y coordinate is 0. All those things you must know. Very basic concept. Okay. The octants we have 8 octants. Like quadrants, we had 4 quadrants, we have 8 octants here, okay. The first octant x, y, z, first 4 octants z coordinate is positive, you can remember, and 5th to 8th octant z coordinate is negative. First 4 octants z coordinate is positive, and 5th to 8th octant z coordinate is negative. So in the first octant x, y are positive. I'll discuss only about x and y. It is behaving like quadrant only. The first 4 octants, if you take z coordinate as positive, of course z coordinate is positive in the first 4 octants, the first 4 octants behaves as the quadrant only. In the first quadrant x and y are positive, no? Similarly in the first octant x and y are positive. In the second octant x is negative, y is positive. In third octant x and y both are negative. Z coordinate is positive, first 4 octants I'm telling. Fourth octant x is positive, y is negative, z is positive. So easily you can remember. In the first 4 octants, z coordinate is positive, and next 4 octants, z coordinate is negative. So reflection of the first octant is the 5th octant. Reflection of the second octant is the 6th octant. Reflection of the third octant is 7th octant. In 7th octant, each x, y, z is negative. And reflection of the 4th octant is 8th octant. Like that we can tell, okay. So first octant x and y positive, even in the 5th octant x and y are positive, you can compare, okay. In the second octant x is negative, y is positive. Same thing happens in the 6th octant, only z coordinate is plus minus, that's the difference. In the third octant x and y are negative, even in the 7th octant x and y are negative. In the 4th octant x and y, x is positive, y is negative. Same thing happens in the 8th octant, x is positive, y is negative, okay. So these are the things you must know, the signs of the x, y, z in different octants. That's what I mentioned already. In the first 4 octants, z coordinate is positive, and the 5th, 6th, 7th and the 8th octant, z coordinate is negative. There are a few questions based on this. The point 1, minus 3, 4 lies in which octant? Here z coordinate is positive. That means it has to come to first 4 octants. In the first 4 octants, which octant it comes? Here x is positive and y is negative. That means it comes to 4th octant. Correct? X is positive, y is negative, z is positive. Therefore, it lies in the 4th octant. 4th octant is the answer. Question asked in the year 2020. A simple question asked. Go on to the next one. Second question we have, similar type of question asked in the year 2022. The octant in which the point lies is, here z coordinate is negative, so it has to come to 5th to 8th. One of the octant from 5th to 8th, because z coordinate is negative. X is positive, y is negative, z is negative, so it comes to 8th octant. The point lies in the 8th octant. Very simple question. Orally we can answer. No need to solve. Correct? Just based on the concept we can answer it. The point lies in the 8th octant. Question asked in the year 2022. Go on to the next one. Distance formula, we know, very familiar distance formula. Root of, if the 2 points are given to you, A is x1, y1, z1 and B is x2, y2, z2. Distance between those 2 points is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. We have some special cases here. The distance of the point P from x-axis is root of b square plus c square. If you drop a perpendicular from the point P A comma B comma C lies in the octant, some octant. From there you drop a perpendicular to x-axis. Any point on x-axis means y coordinate and z coordinate is 0. So corresponding point on x-axis will be, I'll call it as Q if you want. Q will be A comma B 0 comma 0, because any point which lies on x-axis, y coordinate is 0, z coordinate is 0. If you apply distance formula, you'll get the answer as root of b square plus c square. Root of a minus a the whole square plus b minus 0 the whole square plus c minus 0 the whole square. Root of b square plus c square. Same thing here. Distance of this point from y-axis. Drop a perpendicular from the point P to y-axis. Any point on y-axis means x-coordinate and z-coordinate is 0. And the y-coordinate remains the same. The corresponding point on y-axis will be, I'll call it as R here. R is, y-coordinate will be same. X-coordinate will be 0. And even z-coordinate is 0. If you apply distance formula between these 2 points, you'll get root of a square plus c square. Root of a minus 0 the whole square plus b minus b the whole square plus c minus 0 the whole square. If you apply, you'll get root of a square plus c square. Same way, distance of this point from z-axis, the corresponding point on z-axis, drop a perpendicular from this point to z-axis. We call this point as S. S will be point on z-axis means x-coordinate is 0, y-coordinate is 0 and c will be c only. If you apply distance formula between these 2 points, you'll get this. Root of a square plus b square, root of a minus 0 the whole square plus b minus 0 the whole square plus c minus c the whole square. Get root of a square plus b square. The perpendicular distance of the point P from xy plane is mod c. So if you take a point P A comma B comma C, drop a perpendicular from this point to xy plane. Xy plane means in that plane z coordinate is 0. Now when you draw the perpendicular, the x coordinate and y coordinate remain the same. So the corresponding point in the xy plane will be A comma B comma 0. And if you apply distance formula between these two, you will get mod C, C minus 0. C or mod C, because C can be negative but distance can't be negative. So this point, corresponding point on the YZ plane means x coordinate will be 0. So corresponding point will be 0 comma B comma C. And if you apply distance formula, root of a minus 0 the whole square plus b minus b the whole square, c minus c the whole square, you get root of a square, which is mod A. Same way, this point on xz plane, when this point is perpendicular drawn from this point to xz plane, y coordinate is 0, a comma 0 comma c I'll get. So distance between these two will be mod of b. Such kind of questions are asked, simple questions even in KCET exams. We'll discuss the questions on this. We have the one question here. The perpendicular distance of the point P from xy plane. So from this point lies in the first octant. From that point, you drop a perpendicular to xy plane. Xy plane means z coordinate is 0. The corresponding point will be what? 6, 7, 0. Correct? Because from this point, a perpendicular is drawn to the xy plane. Any point in xy plane means z coordinate is 0. So x and y remains the same. Now if I apply distance formula, I will get the answer as 8 root of 6 minus 6 the whole square plus 7 minus 7 the whole square. Correct? Those two are 0. 8 minus 0 the whole square. 8 square root of 8 square root 64 equal to 8. Answer is 8. Question asked in the year 2017. Just drop a perpendicular from the point to the xy plane. Xy plane means z coordinate is 0. X-axis means y coordinate and z coordinate is 0. All those things you must know. Very simple question asked. Okay. So the point x remains the same, x coordinate remains the same, y coordinate is same, z coordinate will be 0. 6, 7, 8 becomes 6, 7, 0. Apply a distance formula. Root of 8 minus 0 the whole square. Root of 64 is equal to 8. Point distance of this point from x-axis. So from this point you drop a perpendicular to x-axis. When you drop a perpendicular to x-axis, x coordinate remains the same. Y coordinate and z coordinate will be 0. So what is the point there? Point Q, I can call it as x-axis. So y coordinate will be 0 and z coordinate will be 0. X coordinate remains the same. A comma 0 comma 0. If you apply distance between these 2 points, I'll get root of a minus a the whole square plus b minus 0 the whole square plus c minus 0 the whole square. If you want to show the steps, PQ is equal to root of, what do you get? A minus a the whole square, correct? A minus a the whole square plus b minus 0 the whole square plus c minus 0 the whole square. Like this we get. A minus a is 0, 0 square is 0. B minus 0 is b square. C minus 0 the whole square, c square. I'll get root of b square plus c square. Distance of this point a comma b comma c from x-axis is root of b square plus c square. Option B is the answer. Question asked in the year 2014. Just drop a perpendicular to x-axis from the given point. Okay, x-axis means y coordinate is 0, z coordinate is 0. The corresponding point on x-axis a comma 0 comma 0. Then apply distance formula. Get root of b square plus c square. Please make a note. Move on to the next one. Question number 3 we have. Distance of this point from the YZ plane. YZ plane means x coordinate is 0. The corresponding point on the YZ plane is x coordinate equal to 0. Correct? X coordinate is 0. Y coordinate you write the same thing. 4 and 5. Y coordinate and z coordinate remains the same because you are dropping the perpendicular to the YZ plane. Any point on YZ plane means x coordinate is 0. Because you are drawing the perpendicular from this point to YZ plane, y coordinate remains the same, even the z coordinate remains the same. If you apply distance formula, it is PQ. It is going to be equal to 3 units. Don't write minus 3. That's why I told mod. Mod is required here. Correct? When I apply distance formula, PQ, you're going to get mod. So PQ is going to be equal to 3. PQ is equal to mod of 3. That is root of, if you want to apply distance formula, minus 3 minus 0 the whole square. Correct? Minus 3 minus 0 the whole square plus 4 minus 4 the whole square plus 5 minus 5 the whole square is equal to root of minus 3 square is 9, 4 minus 4 0, 5 minus 5 0, root of 9 is equal to 3. 3 is answer, not minus 3. So question asked in the year 2025, most recent question asked on 3-dimensional geometry. Correct? Drop a perpendicular from the given point to the YZ plane. YZ plane means x coordinate is 0 and y coordinate, z coordinate remains the same. Apply distance formula. Directly you can tell mod of minus 3 which is plus 3. Okay. Move on to the next one. We have the foot of the perpendicular and image of the point with respect to x-axis, y-axis, z-axis and also with respect to xy plane, yz plane and zx plane. Okay, so the point is given a comma b comma c. Some point, it lies in space. From that point, if you draw the perpendicular to xy plane, you want to find the foot of the perpendicular. Perpendicular drawn from the point to xy plane. What is the foot of the perpendicular? When you draw the foot of a perpendicular to xy plane, z coordinate is 0, correct? So any point on xy plane means z coordinate is 0. X and y remains the same. If you draw the perpendicular from the point to the yz plane, x coordinate is 0 and y and z remains the same. Similarly, perpendicular drawn to the xz plane. XZ plane means y coordinate is 0. X and z remains the same. Hope is clear. So when a perpendicular is drawn from the point to xy plane, x coordinate and y coordinate remains the same and z coordinate will be 0. If you draw the perpendicular from the given point to xz plane, x and z coordinate remains same and y coordinate will be 0. Correct? Xz plane. Yz plane means x coordinate is 0. Y and z remains the same. Clear? So foot of the perpendicular from the point to the planes, xy plane, yz plane and zx plane. Next we have the foot of the perpendicular drawn from the point to x-axis, y-axis and z-axis. So from the point, the perpendicular is drawn to the x-axis. So x-axis means y coordinate and z coordinate is 0. X coordinate remains the same. If you draw the perpendicular from the point to y-axis, any point on y-axis means x coordinate and z coordinate is 0 and y coordinate remains the same. Easily you can remember. And the perpendicular is drawn to the z-axis means x coordinate and y coordinate is 0 and z coordinate remains the same. X and y becomes 0 because the point lies on z-axis. X coordinate is 0, y coordinate is 0, z coordinate will be c, same as this point. Okay, so next we got image of this point with respect to the different planes, xy plane, yz plane and zx plane. Also image of the point with respect to x-axis, y-axis, z-axis. Image is also called as reflection. Remember, image word is also called as reflection. Same words, same meaning both. Image is also called as the reflection of the point. Reflection of the point with respect to xy plane. So when you take a given point a comma b comma c, okay, it lies in space. If you want to find the image of the point with respect to xy plane, drop a perpendicular to the xy plane, okay, and that is the point on the xy plane will be the foot of the perpendicular. The foot of the perpendicular is going to be the midpoint of the given point and the image point. Xy plane is here, the point is here, given point, image point will lie below the xy plane, okay. So the point is given to you, the foot of the perpendicular is going to be the midpoint of the given point and the image point, remember that. So when they ask image of the point with respect to xy plane, just change the z coordinate sign. A, B remains the same, C becomes minus C. So that if you apply midpoint formula for these two, you should get the foot of the perpendicular. Foot of the perpendicular to the xy plane is A comma B comma 0. No? If you apply midpoint formula, you will get the foot of the perpendicular should be the midpoint of the given point and the image point. It always happens. If they ask yz plane, x coordinate sign should change. Remaining y and z remain the same. Say B, C. A will become minus A. If that's xz plane, y coordinate sign will change. B becomes minus B. X and Z remains the same. Okay. XY plane, YZ plane, ZX plane. If you get confused with this, just remember that the foot of the perpendicular should be the midpoint of the given point and the image point. That will help you always. Same story applies even for the axis also. X-axis, Y-axis and Z-axis. So image of the point with respect to x-axis, y-axis, z-axis. So x-axis means you change y and z. X remains the same. Okay. B becomes minus B, C becomes minus C. Y-axis means what? Y-axis means x coordinate changes and z coordinate changes. Y coordinate remains the same. Okay. Z-axis means x and y sign will change. A becomes minus A, B becomes minus B, C will be same as it is. So all these things you must know. Image of the point with respect to the given planes, xy plane, yz plane, zx plane. Also with respect to axis, a given x-axis, y-axis, z-axis. Same story works here also. The foot of the perpendicular is going to be the midpoint of the given point and the image point. Okay. So next one we have question here. Reflection. As I told, image is also called as reflection. Reflection of the point alpha, comma, beta, comma, gamma in the xy plane. So xy plane means z coordinate should be 0 for foot of the perpendicular. Just change the sign of z coordinate. When you want to find reflection of this point with respect to xy plane, just change the sign of z coordinate. Alpha, beta remains same. X and y coordinate remains same. Z coordinate you change the sign. If it is foot of the perpendicular on the xy plane, z coordinate becomes 0. Now z coordinate to change the sign. So it becomes alpha, comma beta, comma minus gamma, which is option D. Very simple, correct? So within 5 seconds we can answer this question. Not a big deal at all. So questions based on the concepts. No need to work out. So reflection of this point in the xy plane means just change the sign of z coordinate. Gamma becomes minus gamma. X and y remains the same because it is reflection. Image is also called as image of the point with respect to xy plane. Question asked in the year 2017. Move on to the next one. Only one question is asked. Section formula already learned in 2-dimensional geometry, correct? Now in 3D geometry we have section formula, and 10th standard we learned what is section formula. The point P is going to divide a line joining 2 points A and B. A is x1, y1, z1. B is x2, y2, z2. In the ratio m is to n internally, mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, mz2 plus nz1 by m plus n. For external division it is minus. mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n, mz2 minus nz1 by m minus n. Also sometimes this result is useful whenever they ask to find the ratio in which the point divides, that in the intermediate step of the derivation of the section formula, m by n is equal to x minus x1 by x2 minus x equal to y minus y1 by y2 minus y equal to z minus z1 by z2 minus z. Okay, so this also it's better to remember. So intermediate step of the derivation of the section formula, this one. Okay, move on to the next one. We have ratio in which the line joining the 2 points is divided by xy plane. So line joining 2 points is divided by xy plane in the ratio of minus z1 is to z2 internally, or z1 is to z2 externally. This negative sign I made it positive, internally becomes externally. The line joining these 2 points is divided by yz plane in the ratio of minus x1 is to x2. Minus x1 is to x2 internally, or x1 is to x2 externally. If the line joining these 2 points is divided by xz plane in the ratio of minus y1 is to y2, or y1 is to y2 externally. Minus y1 is to y2 internally, or y1 is to y2 externally. Suppose if you want to show this, if you take divided by xy plane means what happens? Z coordinate is 0. If you put z coordinate is 0, if you equate these two, you'll get m by n is equal to, correct? Put z coordinate equal to 0. 0 minus z1 divided by z2 minus 0. Z coordinate is 0, correct? So m by n is equal to, I am getting minus z1 divided by z2. That is what we have. M by n is equal to minus z1 by z2. If a line joining 2 points is divided by xy plane means z coordinate is 0. Put z equal to 0 in this. Equate the first and last. We'll get m by n equal to minus z1 by z2. The ratio is minus z1 is to z2 internally. Minus z1 is to z2 internally. That is what we have here. Or z1 is to z2 externally. Yz plane means you put x equal to 0. If you put x equal to 0, I'll get this. M by n is equal to minus x1 by x2, correct? X minus x1 by x2 minus x2. Then you put x equal to 0. You'll get minus x1 is to x2 internally, or x1 is to x2 externally. Similarly, the third one. Okay, one such question is found here in the year 2019. They asked the xy plane divides the line joining the points in the ratio what? So xy plane means the ratio is minus z1 is to z2. Xy plane divides in the ratio minus z1 is to z2. Remember this. Minus z1 is to z2. That is minus z1 is how much? Minus 5. z2 is minus 3, correct? So minus of minus 5 is to z2 is minus 3. Minus of minus 5 plus 5. 5 is to minus 3. This is for internally, correct? Minus z1 is to z2 internally. If you want to remove this negative sign and make it positive, internally becomes externally. 5 is to 3 externally. 5 is to 3 externally. 5 is to 3 externally. Option C is the answer. Hope it's clear. The xy plane divides the lines joining 2 points in the ratio of minus z1 is to z2. Minus Z1 is minus 5 and Z2 is minus 3. Minus of minus 5. 5 is to minus 3 internally or 5 is to 3 externally. Option C is the answer. Question asked in the year 2019. XY plane divides in the ratio of minus Z1 is to Z. YZ plane divides in the ratio minus X1 is to X2. Okay. XZ plane divides in the ratio minus Y1 is to Y2. Hope it's clear. Based on the section formula, we have all those things. Next, we have centroid of a triangle. Centroid coordinates is given by this x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3, comma z1 plus z2 plus z3 by 3. Centroid. Centroid is the point of intersection of the medians of a triangle. You must know this. There are three medians for a triangle. Median means the line segment joining the vertex to midpoint of the opposite side. Because there are three medians for a triangle. Point of intersection of the medians of a triangle is called as centroid of a triangle. And if you want, you can represent a centroid of a triangle like this. Centroid of a triangle is like this. So triangle ABC is there. Okay. Three medians. From the vertex, say, draw the line segment. This is a median, one median. This is another median, BE. This is CF. Three medians are there for a triangle. Point of intersection of the medians of a triangle is called as centroid. Centroid divides the median in the ratio 2:1. Centroid is dividing the median in turn in the ratio 2:1. A to G, the distance is 2 units. Then G to D, the distance is 1 unit. Centroid divides the median internally in the ratio 2:1. You must know this. Okay, it's a basic property of a centroid of a triangle. Median means the line segment joining the vertex to the midpoint of the opposite side. Okay, AD is the median, B is the median, CF is the median. Three medians. Where they intersect, that point is called as centroid of a triangle. Centroid is given by these, the coordinates. If A, B, C are the vertices of a triangle, we can find the centroid of a triangle is in this. Okay. And D is the midpoint of BC here. E is the midpoint of AC. F is the midpoint of AB. And if you want to find length of AG, it is going to be 2/3 of the length of the median. If you want to find length of GD, it is going to be 1/3 of the length of the median of the triangle. Length of AD. Okay. So all those things you must know. GD is 1/3 of AD and AG is 2/3 of AD. So all those things you must know. And many other properties are there, interesting properties of the centroid of a triangle. That is explained in the next one. Okay, the next slide we have centroid of triangle ABC, same as centroid of the triangle DEF, where DEF are the midpoints of the sides of a triangle. Suppose there is a triangle ABC like this. Triangle ABC is that. Okay, triangle ABC is there. DEF are the midpoints. D is the midpoint of BC, E is the midpoint of AC, F is midpoint of AB, D, E, F are the midpoints of the sides of a triangle. So centroid of triangle ABC is going to be same as centroid of the triangle DEF, where DEF are the midpoints of the sides of the original triangle. Okay. So centroids will be same for triangle ABC and centroid of the triangle DEF. Both are going to be same. It is GL called. G is the centroid. Centroid divides the median. Already explained this. In a non-equilateral triangle, centroid divides the orthocenter and circumcenter internal ratio 2:1. So like this, they are always collinear. Centroid divides orthocenter and circumcenter. Orthocenter is H and circumcenter is S. Centroid is going to divide the orthocenter and circumcenter in the ratio 2:1 internally. Okay. Also, we can tell more generally 3G equal to 2S plus H. 3G is equal to 2AS plus H. By using section formula, we have this. All these things required for even JEE exams once the question was asked based on this. Okay. In 2025 also one question was asked, I think. So 3G is equal to 2S plus H. In vectors they ask this kind of question. Okay. They can ask even in vectors. 3G is equal to 2S plus H. This is the formula. So centroid divides the orthocenter and circumcenter in the ratio 2:1. 2 into S plus 1 into H by 2 plus 1 is equal to G. By applying section formula, crisscross, applesauce, multiplying 2 into S plus 1 into H. 2S plus H by 2 plus 1 correct? That is going to be equal to G. So 3G equal to 2S plus H. If you know the orthocenter and centroid, we can find the circumcenter using this relationship. This happens in a non-equilateral triangle. In an equilateral triangle, everything is going to coincide. Centroid, orthocenter, circumcenter, incenter, everything coincides. Okay, all coincides. So all those things I explained here. Okay, all the points are not required here for working out the problems on PYQs, but still I'm explaining all the concepts here. Okay. One question we have, the midpoints of the sides of a triangle are given, then the centroid of the triangle is how much? So we know that centroid of the triangle is same as centroid of the triangle formed by the midpoints, correct? As I explained here, centroid of the triangle ABC is same as centroid of the triangle formed by the midpoints. So you find the centroid of this triangle, that will be same as the centroid of the triangle formed. Centroid of the triangle formed by the midpoints is same as centroid of the triangle. So the required is what? Just apply the formula x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. Centroid of the triangle is equal to, what is the formula? x1 plus x2 plus x3 by 3. 1 plus 0 plus 2 divided by 3. x1 plus x2 plus x3 divided by 3. y1 plus y2 plus y3 by 3. 5 plus 4 plus 3. 5 plus 4 plus 3 divided by 3. Minus 1 plus minus 2 plus 4 divided by 3. 3 by 3 is 1. 5 plus 4, 9. 9 plus 3, 12. 12 by 3 is 4. Here minus 1, minus 2, minus 3. Minus 3 plus 4, 1. 1 by 3. Correct? Centroid is 1, 4, 1 by 3 is answer. Option B. Question asked in the year 2021. Just asking to find centroid of the triangle where midpoints of the sides of the triangle are given. Centroid of the triangle, same as centroid of the triangle formed by the midpoints. x1 plus x2 plus x3 by 1 plus 0 plus 2, 3 by 3, 1. 5 plus 4, 9 plus 3, 12, 12 by 3, 4. Minus 1, minus 2, minus 3, minus 3 plus 4, 1, 1 by 3. Correct? So, we get like this. Please make a note. Just a simple question is asked on finding centroid of a triangle. Move on to the next one. We have area of quadrilateral. 4 vertices of a quadrilateral is given to you. The area of quadrilateral is half into magnitude of AC cross BD to find area of a quadrilateral. One such question is found. Okay. So we have a question here. Area of the quadrilateral formed by the vertices A, B, C, D. Okay. So find out AC and BD here. Find out vector AC here first. Vector AC is equal to, defined as position vector of C minus position vector of A. OC minus OA. OC minus OA. 4, 5, 0. Correct? 4, 5, 0 minus 0, 4, 1. This is equal to how much? C minus A. Correct? OC minus OA. 4 minus 0 is 4. 5 minus 4 is 1. 0 minus 1 minus 1. AC. BD is how much? BD is equal to vector OD minus vector OB. Vector OD is how much? 2, 6, 2. 2, 6, 2 minus vector OB is 2, 3, minus 1. Subtract. Correct? OD minus OB. 2 minus 2, 0. 6 minus 3 is equal to 3. 2 minus minus 1. 2 plus 1, 3. AC cross BD find out. AC cross BD. Then find out its magnitude. Multiply by half. AC cross BD is determinant of I, J, K. AC is 4, 1, minus 1. BD is 0, 3, 3. Expand this determinant. How to find cross product we know. The first row will be I cap, J cap, K cap. Second row is components of vector AC. 4 minus 0, 4. 5 minus 4, 1. 0 minus 1, minus 1. BD is 2 minus 2, 0. 6 minus 3, 3. 2 minus minus 1, 3. Expand this. Then find magnitude. Multiply by half. We'll get area of the quadrilateral. So this is I cap into, leaving first column, first row. 3 minus minus 3. 3 plus 3 is 6. Minus j cap into, leaving second column, first row. 12 minus 0. 12 plus k cap into, leaving third column, first row. 4 minus 0. 4. Correct. 3 plus 3, 6. Minus j cap into 12 minus 0, 12. Plus k cap into 12 minus 0, 12. K cap into 4 into 3 is 12. No, sorry. K cap into, correct, no, j cap into 12 minus 0, 12. K cap into also it is 12 minus 0, 12. Find out its magnitude now. Multiply by half. Can take 6 common here, correct? AC cross BD. AC cross BD is equal to how much? 6 is common. I cap minus 2j cap plus 2k cap. 6 is taken common. If you find magnitude of this, magnitude of 6 is 6 only. Magnitude of 6 is 6 only. Magnitude of this vector is root of 1 square 1 minus 2 square 4 plus 2 square 4, which is 6 into root 9. Root 9 is 3. 6 into 3 is 18. Correct? We want to find area of the quadrilateral. This is half into magnitude of AC cross BD, which is 9. Half into 18 is 9. Because area of the quadrilateral is half into magnitude of AC cross BD. Right here itself. Area of the quadrilateral is half into magnitude of AC cross BD. It is equal to half into magnitude of AC cross BD is how much? We got 18. Correct? Root 9 is 3. 3 into 6, 18. So half into 18, which is equal to 9. 9 square meters. Question asked in the year 2021. Please make a note. Move on to the next one. Direction cosines and direction ratios we have. If alpha, beta, gamma are the angles made by a line with positive x-axis, positive y-axis and positive z-axis, then alpha, beta, gamma are called direction angles. Cos alpha, cos beta, cos gamma are called direction cosines. And they satisfy certain things, cos square alpha plus cos square beta plus cos square gamma is equal to 1, correct? Sin square alpha plus sin square beta plus sin square gamma equal to cos 2 alpha plus cos 2 beta plus cos 2 gamma is minus 1. Very important, all these three. Even for board exams, they can ask questions on this for fill in the blanks. Correct? And if you reverse the direction of the line, the direction angles becomes pi minus alpha, pi minus beta, pi minus gamma. They are supplements. And the direction cosines in this case will be minus cos alpha, minus cos beta, minus cos gamma. And any three numbers which are proportional to the direction cosines are called as direction ratios. You must know this. And if A, B, C are the direction ratios of a line, then direction cosines is plus or minus A by root of A square plus B square plus C square, plus or minus B by root of A square plus B square plus C square, plus or minus C by root of plus or minus root of A plus or minus C by root of A square plus B square plus C square. If you know direction ratios, we can find direction cosines using this. And also we can find direction ratios of line joining 2 points. If a line joins A x1, y1, z1 and B x2, y2, z2, direction ratios are x2 minus x1, y2 minus y1, z2 minus z1, and direction cosines are x2 minus x1 by AB, y2 minus y1 by AB, z2 minus z1 by AB, where AB is this distance formula. Okay. And for a directed line, direction cosines are unique, and for a line there can be infinitely many direction ratios. All these things you must know. Mainly you must know the results on direction cosine. Sum of the squares of the direction cosines equal to 1. This is the most important. Useful to find the third angle gamma. If alpha and beta are given, the third angle gamma can be calculated using this result. Cos square alpha plus cos square beta plus cos square gamma equal to 1. Sin square alpha plus sin square beta plus sin square gamma equal to cos 2 alpha plus cos 2 beta plus cos 2 gamma equal to minus 1. 3 most important results. And if A, B, C are direction ratios, we can find direction cosines. Plus or minus A by root of, plus or minus B by root of, plus or minus C by root of A square plus B square plus C square. If you know direction ratios, we can find direction cosines. If you know, if the 2 points are given, the line joining those 2 points, you can find direction ratios. You can find direction ratios of lines joining the 2 points. You can find direction cosines of line joining the 2 points. Okay, so all those things you must know. And if alpha, beta, gamma are direction angles, cos alpha, cos beta, cos gamma are called direction cosines. And if a vector is given, say xi plus yj plus zk, you can find out its direction ratios as x, y, z. Coefficient of I cap, j cap, k cap will give direction ratios, and x by root of x square plus y square plus z square, comma y by root of x square plus y square plus z square, comma z by root of x square plus y square plus z square gives direction cosines. All those things you must know. There are some questions based on this we'll take up, and also given the note of this direction cosines of x-axis are 1, 0, 0. For x-axis, alpha is equal to 0. Angle made by x-axis with x-axis 0. Angle made by x-axis with y-axis, that is 90 degree. For x-axis, alpha is equal to 0, beta is equal to 90 degree, gamma is equal to 90 degree. Direction cosines will be cos 0, cos 90 degree, cos 90 degree. Correct? Cos 0 is 1, cos 90 degree is 0. Correct? So this is cos 0 is 1, cos 90 degree is 0, cos 90 degree is 0, 1, 0, 0. Direction cosines of x-axis. Similarly, direction cosines of y-axis. Here alpha is equal to angle made by y-axis with x-axis, that is alpha, that is 90 degree. Alpha is angle made by the line with x-axis. My line is y-axis. So angle made by y-axis with x-axis 90. Angle made by y-axis with y-axis 0. Angle made by y-axis with z-axis, that is going to be 90 degree. So direction cosines will be cos 90 degree, comma cos 0 degree, comma cos 90 degree. Cos 90 degree is equal to 0. Cos 0 is 1. Cos 90 degree is 0. 0, 1, 0. Direction cosines of y-axis. Same way you can find out for z-axis 0, 0, 1. And if a line makes equal angles with the positive coordinate axis, then the direction cosines are plus or minus 1 by root 3, plus or minus 1 by root 3, plus or minus 1 by root 3. When a line makes equal angles with the coordinate axis, we have alpha is equal to beta is equal to gamma. Correct? So we have cos square alpha plus cos square beta is same as alpha, gamma is also same as alpha. So we get like this, 3 cos square alpha is equal to 1. Cos square alpha is 1 by 3. So cos alpha is plus or minus 1 by root 3. So cos beta also plus or minus 1 by root 3. Cos gamma also plus or minus 1 by root 3. When a line makes equal angles with a positive coordinate axis, we have direction cosines plus or minus 1 by root 3, plus or minus 1 by root 3, plus or minus 1 by root 3. And this is also quite useful. If you know the magnitude of vector r and you know the direction angles, we can use this and write the position vector of the point. Okay. So position vector of the point could be written, vector r could be written as magnitude of vector r into cos alpha I cap plus cos beta j cap plus cos gamma k cap. Problems we have on this. If a line makes an angle of pi by 3 with each of x and y axis, then the acute angle made by z axis is how much? So alpha is pi by 3, beta is pi by 3. A line is making angles of x axis, angle made by the line with x axis is pi by 3. Angle made by the line with y axis also pi by 3. Want to find acute angle made by the line with z-axis. Made by the line with z-axis. Made by the line with z-axis. Gamma is equal to how much you have to find out? Acute angle made by the line with z-axis. Gamma you have to find out. We have the result. Cos square alpha plus cos square beta plus cos square gamma equal to 1. Use this. Sum of the squares of direction cosines equal to 1. What we have is cos square pi by 3 plus cos square pi by 3 plus cos square gamma equal to 1. Cos pi by 3 is 1 by 2. 1 by 2 square is 1 by 4. Cos pi by 3 is 1 by 2. 1 by 2 square is 1 by 4. Plus cos square gamma is equal to 1. 1 by 4 plus 1 by 4 is half. 1 minus half is half. So cos square gamma is half, I am getting. Cos square gamma is equal to half. So cos gamma is plus or minus 1 by root 2. Cos gamma is plus or minus 1 by root 2. Correct? 1 by 4 plus 1 by 4 is half. 1 minus half is half. Cos square gamma half. So cos gamma is plus or minus 1 by root 2. So cos gamma is 1 by root 2. Cos gamma is minus 1 by root 2. Two possibilities we have. Correct? Cos gamma is 1 by root 2 means gamma is 45 degree or pi by 4 I can write. That's an acute angle. Correct? Cos gamma is minus 1 by root 2 means gamma is 3 pi by 4. So gamma is pi by 4 or 3 pi by 4. But they asked to find acute angle. So gamma is pi by 4. This is rejected, this is accepted. Gamma equal to pi by 4 is answer. Angle made by the line with z-axis is pi by 4. Option A. Question asked from the year 2020. Move on to the next one. Line makes angles 90 degree, 60 degree and theta with x, y and z axis respectively. Theta is acute. Find the value of theta. So angle made by the line with x, y and z axis are given like this. Given alpha as 90 degree. Beta is equal to 60 degree. And gamma is equal to theta. Correct? You have to find theta. Theta is acute. We have cos square alpha plus cos square beta plus cos square gamma equal to 1. Using this, we can find out cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is cos square 90 degree plus cos square 60 degree plus cos square theta is equal to 1. Cos 90 degree is 0. Cos 60 degree is half. Half square is 1 by 4 plus cos square theta is equal to 1. So this is cos square theta is equal to 1 minus 1 by 4 which is 3 by 4. Correct? So cos theta is equal to plus or minus root 3 by 2. Cos theta is root 3 by 2 means theta is equal to pi by 3, pi by 6. Correct? Cos 30 is root 3 by 2. 30 is pi by 6. Another possibility is cos theta is minus root 3 by 2. Correct? This gives theta equal to pi by 6. As you know, cos pi by 6 is root 3 by 2. This is pi minus pi by 6 which is 5 pi by 6. They told to find the acute angle. Correct? So answer is pi by 6. Pi by 6 is the acute angle. Cos pi by 6 root 3 by 2. Correct? Cos 5 pi by 6 is minus root 3 by 2. This is obtuse angle. This is obtuse angle. They asked to find the acute angle. Pi by 6 is answer. Question asked in the year 2025. On to the next one. A line makes angles of pi by 3 with each of x and y axis. Then acute angle made by the line with z axis. Alpha and beta both are pi by 3 here. Alpha is pi by 3. Beta is pi by 3. Gamma is equal to, you have to find out acute angle made by the line with z axis. Using cos square alpha plus cos square beta plus cos square gamma is equal to 1. Sum of the squares of direction cosines equal to 1. Cos square pi by 3 plus cos square pi by 3 plus cos square gamma is equal to 1. Cos pi by 3 is 1 by 2. 1 by 2 square 1 by 4. 1 by 2 square 1 by 4. Correct? Plus cos square gamma is equal to 1. 1 by 4 plus 1 by 4 is half. So cos square gamma is 1 minus half, which is equal to half. So cos gamma is plus or minus 1 by root 2. So gamma is either pi by 4 or 3 pi by 4. Cos gamma is 1 by root 2 for gamma is pi by 4. Cos gamma is minus 1 by root 2 for gamma is 3 pi by 4. They has to find the acute angle. So pi by 4 is the answer. Same question asked, I think, here. 2020 and 2023. Correct? Same question. Move on to the next one. Equation of line. Line passing through a point and parallel to given vector. R is equal to A plus lambda B. And Cartesian form is this. X minus x1 by A equal to y minus y1 by B equal to z minus z1 by C. Line is passing through a point whose position vector is vector A and it is parallel to vector B. Parallel to vector B. Line is passing through the point whose position vector is vector A and it is parallel to vector B. Equation is R is equal to vector R is equal to A plus lambda B. In Cartesian form we have this. X minus x1 by A equal to y minus y1 by B equal to z minus z1 by C. Line is passing through the point x1, y1, z1 and it is parallel to the line whose direction ratios are A, B, C. Okay, and the line passing through 2 points, the vector equation and the Cartesian form we have. R is equal to A plus lambda times B minus A. Line is passing through 2 points whose position vectors are vector A and vector B. Correct? Passing through 2 points. And it is in the Cartesian form we have this symmetry form also we can call x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. Even though it's deleted from this, now it's deleted from the book, actually in the NCERT book, but still I am discussing it because it is useful from various competitive exams. It is deleted, the second form of a line passing through 2 points whose position vectors are vector A and vector B. R is equal to vector A plus lambda times B minus A. This is deleted from the NCERT textbook, but still I am discussing it because it is useful here and there for various competitive exams. There are a few questions based on this equation of a line which is joining the 2 points. Question asked in the year 2021. So line joining 2 points. Take the first point as x1, y1, z1. Of course, the options are found in the Cartesian form. Take the first point as x1, y1, z1. Second point as x2, y2, z2 and apply the formula, get the answer. This is x1, y1, z1. This is x1, y1, z1. This is x2, y2, z2. Equation of the line is what? X minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1. First point is x1, y1, z1. So substitute the point here. X minus 3 divided by x2 minus x1, 1 minus 3. Y minus y1, y1 is 4 divided by y2 minus y1, minus 2 minus 4. Correct? Y2 minus y1 equal to z minus z1 divided by z2 minus z1, 7 minus 11. Simplify this. X minus 3, y minus 4, z minus 11. 1 minus 3, minus 2 minus 4, 7 minus 11, correct no? That is x minus x plus 3 divided by 4. This is equal to y minus 4 divided by minus 6 is equal to z minus 11 divided by minus 4, correct? So denominator is 4 minus 6 minus 4, or I can write it as because they are direction ratios, I can write it as cancel 2 2s are 2 3s are 2 2s are. I can write this as x plus 3 divided by minus 2. I'll divide by minus 2 for each of them. So that y minus 4 divided by 3 is equal to z minus 11 divided by 2 divided by minus 2. Okay, we get minus 2, 3, 2, which is found here. X plus 3 by minus 2, y minus 4 by 3, z minus 11 by 2. Option B is the answer. Correct, no? Option B. Minus 2, 3, 2, denominator. Numerator everywhere it is same, I think, no? No, these two are different. These two can't be the answer because z plus 11 is given. This is definitely not possible because plus 11 is there. Among these two, we should check. Among these two, we should check. And denominator should be 2, 3, it can be 2 minus 3 minus 2 or minus 2, 3, 2. Both are same because there can be infinitely many direction ratios for a given line. So answer is option B, minus 2, 3, 2, denominator. Passing through the point, minus 3, 4 and 11. X plus 3, y minus 4, z minus 11. So question asked in the year 2021. Move on to the next one. Equation of the line which is passing through the point 0, 1, 2 and perpendicular to this line. Actually, we know the condition for perpendicular lines is a1, a2 plus b1, b2 plus c1, c2 equals, that comes in the next section actually. But still I have included the question here itself. It is passing through the point 0, 1, 2. So line will be x minus 0 divided by y minus 1 divided by z minus 2 divided by. Passing through the point 0, 1, 2. And it is perpendicular to this line. So the required line is passing through this, that is x1, y1, z1, and it is perpendicular to this line. Correct? So if it is perpendicular to this line, which of the option is going to satisfy the condition that a1, a2 plus b1, b2 plus c1, c2 equals 0? If you take this line and the first option, whether we get a1, a2 plus b1, b2 plus c1, c2 equals 0, you should check. What is 2 into minus 3? For the first option, if you are taking 2 into minus 3, minus 6, 3 into 4, 12, minus 2 into 3, minus 6, minus 6, minus 6, minus 12 plus 12, 0, satisfies. Correct? a1, a2 plus b1, b2 plus c1, c2 is 0. Numerator everywhere is same, no? X, y minus 1, z minus 2. That is same. Numerator is same everywhere. Correct? Denominator is important. So first option satisfies. So answer is option E. Denominator is minus 3, 4, 3. If you take option B, if you take the given line and option B, what do you get? 2 into 3, 6. 3 into 4, 12. Minus 2 into 3, minus 6. Minus 6 plus 6 becomes 0, but it becomes 12. This product is not 0. So this is not the answer. This is the answer, this is not the answer. Similarly, I can say option C is not the answer. Take the given line and the option C, verify a1, a2 plus b1, b2 plus c1, c2, whether it is 0 or not. 2 into 3, 6. 2 into 3, 6. Plus 3 into minus 4, minus 12. Plus minus 2 into 3, minus 6. This will become minus 12. It is not so. Option D you take. Take the given line. Given line is here. Correct? The option D is here. 2 into 3, 6. I am verifying a1, a2 plus b1, b2, 3 into 4, 12 plus c1, c2, minus 2 into minus 3 plus 6. How much? This is 24 is not equal to 0. Correct? So option A is the answer. Question asked in the year 2025, this year. Move on to the next one. Angle between two lines. Given lines in the vector form, vector r equal to a1 plus lambda b1, vector r equal to a2 plus mu b2. Then theta is the angle between the two lines. Theta is equal to cos inverse of, we can write. Theta is the angle between the lines. Then cos theta is mod of b1 dot b2 by magnitude of vector b1 into magnitude of vector b2. In Cartesian form, the lines are given like this. X minus x1 by a1 equal to y minus y1 by b1 equal to z minus z1 by c1. Another line is given like this. X minus x2 by a2 equal to y minus y2 by b2 equal to z minus z2 by c2. Okay, theta is the angle between the lines. Then cos theta is equal to mod of a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square, root of a2 square plus b2 square plus c2 square. Learn these formulas. Quite important to work out the problems, to find angle between two lines. They can give in the vector form or they can give in the Cartesian form. Also, we have condition for parallel lines and perpendicular lines. Parallel lines A1 by A2 equal to B1 by B2 equal to C1 by C2. For perpendicular lines A1 A2 plus B1 B2 plus C1 C2 equal to 0. Perpendicular lines condition is theta is equal to 90 degree or pi by 2. Here theta is equal to 0 degree for parallel lines. And also if they give direction cosines, instead of giving direction ratios, if they give direction cosines, the formula is this: theta equal to cos inverse of mod of L1 L2 plus M1 M2 plus N1 N2. Okay, so the direction ratios, see A1 A2, I can separate the terms here. Numerator is sum of 3 terms. No, numerator contains 3 terms here. A1 A2 by denominator plus B1 B2 by denominator. A1 by root of, this will be L1. Okay, A2 by root of, this will be L2. B1 by root of, that is M1. B2 by root of, that is M2. C1 by root of, that is N1. C2 by root of, that is N2. L1 L2 plus M1 M2 plus N1 N2. That is how I get. From this formula itself, we got that formula. Here A's, B's and C's are direction ratios. L's, M's, N's are direction cosines. From the direction ratios, we got direction cosines. From this formula itself, the new formula is deduced here in terms of direction cosines. Even one such question is asked based on this formula. Okay, so quite important. There are problems based on this. Angle between two lines. See that the lines are in the standard form. Coefficient of x, y, z should be 1. The lines are in the standard form means coefficient of x, y, z all should be equal to 1. See, x plus 3 by 5, y minus 1 by 5, z plus 3 by 4. Means coefficient of x, y, z is 1 for the first line. Even for second line, coefficient of x, y, z is 1. See, correct? So lines are in the standard form. So I want to write the values of A1, B1, C1, A2, B2, C2. Looking at the lines, I write the values of A1, B1, C1. Here A1 is equal to 3. Denominators are A's, B's and C's. A1 is 3, B1 is 5 and C1 is 4. A1, B1, C1. A1, B1, C1. Denominators are A's, B's and C's. Here for second line, A2 is equal to 1, B2 is equal to 4 and C2 is equal to 2. Cos theta is equal to, we have mod of A1 A2 plus B1 B2 plus C1 C2 divided by root of A1 square plus B1 square plus C1 square multiplied by root of A2 square plus B2 square plus C2 square is equal to mod of A1 A2 3 into 1 3 plus B1 B2 5 into 4 20 plus C1 C2 4 into 2 8, correct, divided by square root of A1 square plus B1 square plus C1 square 3 square 9 5 square 25 plus 4 square 16 root of A2 square plus B2 square plus C2 square 1 square 1 4 square 16 2 square 4. This is 28 plus 3 31. Denominator is root 50, which is 5 root 2 we can write. This is the root of 21, correct. This is 31 divided by this is root 50 is root of 25 into 2, which is 5 root 2 into root 21, which could be written as 31 divided by 5 into root of 21 root 2 is root of 42. This is cos theta. So theta is cos inverse of 31 divided by 5 root 42. This is the answer. Cos inverse of 31 by 5 root 42. Option A is the answer. Just a simple question, a board exam level type of question. Finding angle between two lines. Both the lines are in the standard form. Its coefficient of x, y, z are 1 here. Correct? Denominators are A's, B's and C's. Apply the formula, substitute the values and get the answer. All these things you can do in no time. Doesn't take much time. Board exam level questions are asked in CET exam. Many times you can find such kind of questions. Okay, the question asked in the year 2022. Please make a note. On to the next one. Angle between the diagonals of the cube is how much? Question asked in the year 2014. Angle between the diagonals of the cube. There are 4 diagonals for a cube. You must know that there are 4 diagonals for a cube. So I'll draw the cube here, represent the cube here. We'll take this as x-axis, this is z-axis, and this is y-axis we'll take. We'll take a cube. Cube has 8 edges, we know. Cube has 8 edges. I'll take one of the edge at the origin only. Another edge on y-axis. This will be 0, a, 0. Any point on y-axis, x coordinate and z coordinate is 0. Because a is the length of the edge of the cube. This point I'll take here, b. b is in the xy plane. c is on x-axis. a, 0, 0. Point B is in the xy plane. XY plane means z coordinate will be 0. Correct? A, 0. Join this. Take like this. A rough sketch. My figure is not so correct. Okay. Only for understanding purpose. They asked to find angle between the 2 diagonals of the cube. Correct? Any 2 diagonals you can find out. There are 4 diagonals for a cube actually. There are 4 diagonals for the cube. We'll take any 2 diagonals. This point is on x-axis. This point is in the xy plane. So z coordinate is 0. O, A, B, C. This is D. This is E, F, G. D is the point in the xz plane. Xz plane means y coordinate is 0. Correct? It will be A, 0, A. XZ plane. The point D is in the XZ plane. XZ plane means y coordinate is 0. Point E is in space. Point E is actually, I'll write here A, A. Point E is A, A. It is in space. Point F is in the YZ plane. YZ plane means x coordinate is 0. 0, A. And G is a point on Z axis. Z axis means x coordinate and y coordinate is 0. A. Like this. The 4 diagonals we can represent now. I'll take any 2 diagonals. There are 4 diagonals for a cube. The 2 diagonals I'll take. One is GB. Another one is CF. The 4 diagonals are, actually I'll mention the 4 diagonals and not represent those. The 4 diagonals of the cube are, 4 diagonals of the cube in this figure are, one is GB, correct? GB is one diagonal. CF is another diagonal. OE is another diagonal. And the last diagonal is AD. You take any 2 diagonals, find out their direction ratios. Line joining 2 points, direction ratios we know how to find. Then you can apply the formula cos inverse of theta equal to cos inverse of mod of A1 A2 plus B1 B2 plus C1 C2 by root of A1 square plus B1 square plus C1 square root of A2 square plus B2 square plus C2 square. You can apply the formula and get the answer. Okay, theta is cos inverse of. I'll take any 2 diagonals. I'll take the diagonal GB and CF. Consider these 2 diagonals. Find the direction ratios of GB. Direction ratios of line joining 2 points we know how to find. X2 minus X1, Y2 minus Y1, Z2 minus Z1. DRs of GB. DRs means direction ratios of GBR. Direction ratios of GBR. G is here, B is here. Find out direction ratios. x2 minus x1. A minus 0. A. Correct? G, B. Look at the points G and B. B is in the xy plane, so z coordinate is 0. G is on z axis, so x and y coordinate is 0. G, B. A minus 0. A minus 0. 0 minus A. Minus A. Correct? A minus 0 is A. A minus 0 is A. 0 minus A is minus A. Next, direction ratios of CF. Direction ratios of CF. C is here, F is here. Direction ratios of CF are 0 minus A, minus A. 0 minus A minus 0. CF. 0 minus A is minus A minus 0, A minus 0, A. Correct? Look at the points C and F and apply the formula. x2 minus x1. 0 minus A minus 0, A minus 0. F is a point in the YZ plane, so x coordinate is 0. And C is a point in the XY plane. C is a point on x axis, so Y and Z is 0. Correct? C is a point on the x axis. So Y coordinate and Z coordinate is 0 there. Now, taking this as A1, B1, C1, A2, B2, C2, apply the formula. Theta is equal to cos inverse of mod of A1, A2, A into minus A square, plus B1, B2, A into A square, minus A into A, minus A square, divided by root of A square plus minus A square, A square plus minus A square, root of here minus A the whole square, same as A square plus A square plus A square. Correct? Minus A square plus A square cancels here. So what you get is cos inverse of, one of them will cancel it, minus A square plus A square, mod of minus A square, same as mod A square, which is A square. This will be root of 3A square, this is root 3 into A. Root 3 into, this is root of 3A square, this is root 3 into A. A into A square cancels. A square cancels, so what you get is cos inverse of 1 by root 3 into root 3. Root 3 into root 3 is 3, 1 by 3. Cos inverse of 1 by 3 is answer. Option A is answer. Any two diagonals you find out, the angle between any two diagonals of a cube is going to be cos inverse 1 by 3 only. If you take angle between diagonal of the cube and the diagonal of the face of the cube where they intersect, the angle is going to be theta equal to cos inverse of root of 2 by 3. That is also there, one question, which is not asked in the KCET exam, so I'm not discussing here. I'll discuss separately when I'm doing the other synopsis part or something else. Okay. Question asked in the year 2014 this was. Okay. Angle between any two diagonals of a cube. There are 4 diagonals. Any two diagonals you take, same angle you're going to get. Okay, angle between any two diagonals of a cube is cos inverse 1 by 3. You can remember it. It's very standard. Question number 3 we have angle between the lines. Question asked in the year 2018. So the first line, I'll write the lines in the standard form. Lines are in the standard form means the coefficient of x, y, z should be 1. So the first line is what? 2x equal to 3y equal to minus z. The first line L1 is 2x is equal to 3y is equal to minus z. Coefficient of x, y, z should be 1. No? To make 1 the coefficients of x, y, z, I'll divide the entire equation by 6, which is LCM of 2 and 3. LCM of 2 and 3 is 6. So divide throughout by 6. Divide throughout by 6. Divide throughout by 6. What do you get? 2x by 6, which is x by 3. 3y by 6, which is y by 2, is equal to z by minus 6. This is the first line. Second line, there also, here coefficients of x and z is seen, 6 and minus 4 respectively. So divide by LCM of 6 and 4. LCM of 6 and 4 is 12. So divide throughout by 12. So that the lines will take the standard form. Second line is 6x is equal to minus y is equal to minus 4z. Divide throughout by LCM of 6 and 4, which is 12. Divide throughout by LCM of 6 and 4, which is 12. Correct? X by 2 I'll get. Y by minus 12 is equal to Z by minus 3. This is my second line. Okay. Now, you see, denominators are direction ratios of the line A1, B1, C1, A2, B2, C2. If you find out A1, A2 plus B1, B2 plus C1, C2, if it comes to 0, directly can conclude that the lines are perpendicular, so that angle between them is 90 degree. Check for that. A1, A2 plus B1, B2 plus C1, C2. A1, B1, A1, B1, C1. This is A2, B2, C2. Denominators. Now, consider A1, A2 plus B1, B2 plus C1, C2. How much? A1, A2. 3 into 2, 6. 3 into 2 plus 2 into minus 12 plus minus 6 into minus 3. 3 into 2, 6. 2 into minus 12 minus 24. Minus 6 into minus 3 plus 18. Correct? A1, A2. 3 into 2, 6. B1, B2, 2 into minus 12, minus 24, minus 6 into minus 3, plus 18. 18 plus 6, 24 minus 24, 0. A1, A2 plus B1, B2 plus C1, C2 comes to 0. Therefore, lines are perpendicular. That means theta is equal to 90 degree. Question asked in the year 2018. First, reduce the given lines to standard form. Standard form is the coefficient of x, y, z all should be equal to 1, unity, plus 1. So divide by LCM of 2 and 3, which is 6. Divide throughout by 6 and write. For the second line, LCM of 6 and 4 is 12. Divide throughout by 12 and write. A1, B1, C1, denominators. A2, B2, C2. Find out the sum of the products of the direction ratios. If it is 0, we can conclude that the lines are perpendicular. Move on to the next one. Question number 4 we have angle between the lines, so direction cosines are. So direction cosines are given here. Correct? This is L1, M1, N1, L2, M2, N2. This is L1, M1, N1, L2, M2, N2. We have the formula theta is equal to cos inverse of mod of L1, L2 plus M1, M2 plus N1, N2 is equal to cos inverse of mod of L1, L2. Multiply and write root 3 by 4 into root 3 by 4. Correct? Root 3 by 4 into root 3 by 4. Plus 1 by 4 into 1 by 4. 1 by 4 into 1 by 4 plus root 3 by 2 into minus root 3 by 2. Root 3 by 2 into minus root 3 by 2. Cos inverse of root 3 into root 3 is 3. 4 into 4, 16. This is 1 by 16. Plus into minus, minus 3 by 4 is equal to cos inverse of how much? 3 by 16 plus 1 by 16. This is 4 by 16. 4 by 16 is 1 by 4. 1 by 4 minus 3 by 4 minus 2 by 4 minus half. Mod of minus half. Mod of minus half is half. Correct? Minus 2 by 4 is minus half. Mod of minus half is half. Cos inverse of 1 by 2 is pi by 3. Question asked in the year 2021. Given direction cosines, compare with L1, M1, N1, L2, M2, N2. Then apply this formula. Correct? In terms of direction cosines. Answer is pi by 3. Move on to the next one. Question number 5 we have. If the lines are mutually perpendicular, find the value of k. First see whether the lines are in the standard form or not. For standard form means coefficient of x, y, z all should be 1. Correct? Coefficient of x 1 here, x minus 1, y minus 2, z minus 3. Coefficient of x, y, z 1 here. here x minus, y minus, z minus. So lines are in the standard form. So denominators will give a1, b1, c1, a2, b2, c2. Here a1 is minus 3, a1 is equal to minus 3, b1 is equal to 2k. All these things we can do, just mind calculation, no need to work out all these things. A1, B1, C1, A2, B2, C2. A1, B1, C1. C1 is 2. A2 is 3k. A2 is 3k. B2 is 1. C2 is minus 5. Mutually perpendicular implies A1 A2 plus B1 B2 plus C1 C2 equal to 0. Correct? A1 A2 minus 3 into 3k minus 9k plus B1 B2 2k into 1 2k plus C1 C2 minus 10 equal to 0. This gives minus 7k is equal to 10, or k is minus 10 by 7. K is minus 10 by 7. Just apply the condition for two lines to be perpendicular to each other. A1 A2 plus B1 B2 plus C1 C2 minus 3 into 3k minus 9k 2k into 1 2k 2 into minus 5 minus 10. This is minus 7k equal to 10. K is minus 10 by 7. Question asked in the year 2024. Go on to the next one. Length of the perpendicular from the point of the line. Given a point and a line, we can find the length of the perpendicular using this shortcut method. Magnitude of AP cross B by magnitude of vector B. Suppose a line L is given to you. A line L is given to you. Okay, whose equation is x minus x1 by A equal to y minus y1 by B is equal to z minus z1 divided by C. A line L is given to you and a point P is given to you. Point P say alpha, beta, gamma. Okay, you can find out the length of the perpendicular using this time saving result. Length of the perpendicular from the point to the line we can find out using this magnitude of AP cross B by magnitude of vector B. B vector is this. Denominator direction ratios are there, no, of this line, that is taken as vector B. Vector B is AI plus BJ plus CK. AI plus BJ plus CK. This is your vector B. And vector point A is the point on the line. The point on the line is x1, y1, z1. The point A is this, x1, y1, z1. And the point P is alpha, beta, gamma. Given point. So AP, you have to find out. AP cross B, magnitude of AP cross B divided by magnitude of vector B will give the length of the perpendicular from the point to the line. There are problems based on this. Also, you can do the actual method, the traditional method also we can do, or you can use this time saving result. Distance between the point and the line, the perpendicular distance from the point to the line is this, magnitude of AP cross B by magnitude of vector B. Okay, vector B is got from this AI plus BJ plus CK, and the point P is a given point. A is a point on this line. Of course, this line is passing through the point x1, y1, z1. That itself is taken as a point A. So you can find out AP. AP is OP minus OA. Vector AP cross B, magnitude of that divided by magnitude of vector B gives the distance between the point and the line. Of course, the perpendicular distance between the point and the line is got. This is quite important concept actually, finding the length of the perpendicular from the point to the line. There are 4 questions asked based on this in the past years. Length of the perpendicular drawn from the point to the line. We can do the traditional method, or else we can do that formula method, the time saving result, magnitude of AP cross B divided by magnitude of vector B. Any method is okay. So the point P is given here, 3 comma minus 1 comma 11, and the line is this. I'll sketch a rough one for you, the figure. The point P is given to be equal to 3 comma minus 1 comma 11. 3 comma minus 1 comma 11, and the line is this, x by 2 is equal to y minus 2 divided by 3 is equal to z minus 3 divided by 4. This line is L, okay? This line is L, we can call. We want to find this length of this perpendicular. We can take this as a lambda, the general point we can write on the line L. From this, x is equal to 2 lambda. If we cross multiply, x is 2 lambda, y minus 2 is 3 lambda, z minus 3 is equal to 4 lambda. What we get from this, x is equal to 2 lambda, y is equal to 3 lambda plus 2, z is equal to 4 lambda plus 3. Let this be any point on the line L. Let that point be Q, I'll take. Q is this point, the foot of the perpendicular. The point Q is this, 2 lambda, 3 lambda plus 2, 4 lambda plus 3. We know that the line L is perpendicular to PQ because Q is the foot of the perpendicular from the point to the line L. Q is the foot of the perpendicular. Find direction ratios of PQ. Direction ratios of PQ. Direction ratios of PQ are x2 minus x1, y2 minus y1, z2 minus z1. 2 lambda minus 3, correct? 2 lambda minus 3. 3 lambda plus 2 minus of minus 1. 3 lambda plus 2 plus 1. 3 lambda plus 3. 4 lambda plus 3 minus 11, that is 4 lambda 3 minus 11, that is minus 8. We get direction ratios of PQ. PQ is perpendicular to L. Direction ratios of the line L are proportional to 2, 3, 4. I'll use a condition for 2 lines to be perpendicular and determine lambda. Once you get lambda, you get the coordinates of Q. Then you can find PQ by using distance formula. That's the idea of this problem. So PQ is perpendicular to line L. PQ is perpendicular to the line L, implies we can use A1, A2, 2 lambda minus 3 into 2. A1, A2 plus B1, B2 plus C1, C2 equal to 0. 2 lambda minus 3 into 2. 2 lambda minus 3 into 2 plus 3 lambda plus 3 into 3. 3 lambda plus 3 into 3 plus 4 lambda minus 8 into 4. This should be equal to 0. What we get from this? 4 lambda minus 6 plus 9 lambda plus 9 plus 16 lambda minus 32 equal to 0. 16 plus 9, 25 plus 4, 29 lambda minus 6 minus 32 minus 41 minus 38 plus 9 minus 29 I'm getting, correct? Minus 6 plus 9 is 3, 3 minus 32 minus 29, that is equal to 29. So I get lambda equal to 1. Lambda equal to 1 I get. Lambda is equal to 1 means I'll get the point Q as, therefore the point Q is, put lambda equal to 1 here, 2 into 1 2, 3 into 1 3, 3 plus 2 5, 4 into 1 4 plus 3 7. Point Q we get. Now I can find PQ. Also we got the foot of the perpendicular. In this method the advantage is even I get the foot of the perpendicular. Q is the foot of the perpendicular. If you want to find image, I can find image also. So image, if you want to find out the foot of the perpendicular, Q is going to be the midpoint of the given point and the image point. Okay. So now the required is length of the perpendicular. Therefore, length of the perpendicular is PQ. Length of the perpendicular is PQ, which is using distance formula, root of 2 minus 3 the whole square, 2 minus 3 the whole square, plus 5 minus minus 1 the whole square, 5 plus 1 the whole square, plus 7 minus 11 the whole square, 7 minus 11 the whole square, PQ. This is root of 2 minus 3 is minus 1 square 1, 5 plus 1, 6 square is 36, correct? 7 minus 11 minus 4 square 16, which is root 53 is the answer. Root 53, option A, the length of the perpendicular. I'll do it by another method, which is the time saving result I told, magnitude of AP cross B by magnitude of vector B. The vector B should be taken as 2i plus 3j plus 4k, and the point P is given. Point A is any point on this line. Anyway, the line passes through the point 0, 2, 3, correct? So I'll take that point and find out AP cross B by magnitude of vector B. Magnitude of AP cross B by magnitude of vector B. That is what we have to find out. Point P is here, correct? I'll take one additional page, can add here. So 3 comma minus 1 comma 11, the point P is 3 comma, the point P is 3 comma minus 1 comma 11, and the line was, and the line is x by 2 equal to y minus 2 by 3, x by 2 is equal to y minus 2 divided by 3 is equal to z minus 3 by 4, x by 2 equal to y minus 2 by 3 equal to z minus 3 by 4, z minus 3 divided by 4, okay. So I should take vector B as this. The line L is there, no, it's parallel to the line whose direction ratios are proportional to 2, 3, 4, 2i plus 3j plus 4k. And the point is, the line is passing through which point? This line is passing through the point 0, 2, 3. That is the point A. Point P is given. Find out vector AP. Find out vector AP. OP minus OA. 3 minus 0. Minus 1 minus 2. Minus 3. Here 11 minus 3. 8. Correct? Vector AP is OP minus OA. 3 minus 0. Minus 1 minus 2. 11 minus 3. Now find out AP cross B. AP cross B is equal to determinant of I cap, J cap, K cap. Vector AP is here 3 minus 3, 8. Vector B is here 2, 3, 4. This is equal to I cap into, leaving first column first row, minus 12 minus 24 minus 36 minus j cap into 3 into 4, 12 minus 16, 12 minus 16 minus 4, 12 minus 16, correct, no? Plus k cap into, leaving third column first row, 9 plus 6, that is 15, correct, no? Leaving first column first row, minus 12 minus 24 minus 36 minus j cap into 12 minus 16 minus 4, k cap into 9 plus 6, 15. Find out magnitude of this. Magnitude of AP cross B, root of 36 square, that is 1296, minus of minus 4 square 16, 15 square is 225. Also find magnitude of vector B. Magnitude of vector B is root of 2 square 4, 3 square 9 and 4 square 16, which is root 29. This is how much? Root of 225 plus 16 is 241. 1296 plus 1296 plus 241. 6 plus 1, 7, 9 plus 4, 13, 1 carry, 4 plus 1, 5, 1537. 3, 7 I'm getting. The distance is given by the formula magnitude of AP cross B divided by magnitude of vector B. Root of 1537 divided by root of 29, which is 29 table. I can cancel this. 29 into 5 is 145. 8 remains, correct? 1537, no, sorry. 1537. 1537 divided by, this is 29 ones are, 29 into 5 is 145, correct? 8 remains, 29 threes are is 87, so root 53 I'm getting. 1537 by root 29, root of 1537 by root 29, root 53. That is what we got, the same answer, correct? You can check. Magnitude of AP cross B by magnitude of vector B, correct? Hence, you can do any method. In this method, you are getting even the foot of the perpendicular. Also, you can find length of the perpendicular by using distance formula between the points P and Q. And also, you can find image of the point. If you apply Q as the midpoint of P and R is the image point, you can find R using midpoint formula. Foot of the perpendicular will be the midpoint of the given point and the image point. On to the next one. Question number 2 of this type. The distance of the point from the line. I'll do the traditional method only. The point is given, line is given. Want to find the distance between the point and the line. So the point is given here. Point is given as P 1, 2, minus 4. 1, 2, minus 4. The line is x minus 3 divided by 2 is equal to y minus 3 by 3. Y minus 3 divided by 3 is equal to z plus 5 divided by 6. This point is QL called. The line is L. Take this as lambda. The general point on this line is x is equal to how much we get? 2 lambda plus 3. Cross multiply. Equate the first one to lambda. X minus 3 is 2 lambda or x is 2 lambda plus 3. Cross multiply and rearrange the terms. 2 lambda plus 3. Y is equal to 3 lambda plus 3. Z is equal to 6 lambda minus 5. This is the point P. This is the point Q. Find direction ratios of PQ. Same concept. PQ is perpendicular to the line. Correct? The point P is this. Point P is 2 lambda plus 3, 3 lambda plus 3, 6 lambda minus 5. Direction ratios of PQ we find out. Direction ratios of PQ are x2 minus x1. This is point Q, sorry. This is the point Q. This is the point Q. P is taken already there. This is point Q. Direction ratios of PQ are PQ x2 minus x1. 2 lambda plus 3 minus 1. 2 lambda plus 2. 3 lambda plus 3 minus 2. That is 3 lambda plus 1. 6 lambda minus 5 plus 4. That is 6 lambda minus 1. x2 minus x1. y2 minus y1. z2 minus z1. Correct? We get direction ratios of PQ like this. 2 lambda plus 2. 3 lambda plus 1. 6 lambda minus 5 plus 4. That is minus 1. 6 lambda minus 1. PQ is perpendicular to line. PQ is perpendicular to the line L. Therefore, A1, A2 plus B1, B2 plus C1, C2 equal to 0. Applying condition for two lines to be perpendicular. 2 into this. 2 into 2 lambda plus 2. 3 into 3 lambda plus 1. 3 into 3 lambda plus 1. Plus 6 into 6 lambda minus 1. Equal to 0. What do you get? 4 lambda plus 4 plus 9 lambda plus 3, 6 into 6, 36 lambda minus 6 equal to 0. 4 plus 9, 13 plus 36, 49 lambda. Correct? 4 plus 3, 7 minus 6, 1. Correct? Plus 1 equal to 0. 4 plus 3, 7 minus 6, 1. Lambda is minus 1 by 49 we get. Lambda is minus 1 by 49. Correct, no? 3, 2 into 2, 4, 3 into 3, 9, 3 lambda plus 1 into 3, 3 into 1, 3, minus 1 into 6, minus 6, 4 plus 3, 7, 7 minus 6, 1. Lambda is minus 1 by 49. Therefore, my point Q is what? Point Q is, substitute here. Lambda is minus 1 by 49. Minus 2 by 49 plus 3. Point Q becomes minus 2 by 49 plus 3. Minus 2 by 49 plus 3. 3 into minus 1 by 49. Minus 3 by 49 plus 3. Lambda is minus 1 by 49. Minus 6 by 49 plus minus 5. Minus 6 by 49 minus 5. Lambda is minus 1 by 49. From this, we get Q is what? Take LCM 49. 49 into 3 is 147. I get 145 by 49. 145 divided by 49. 49 into 3 is 147. So this is 144 by 149. 144 by 49. LCM is 49 here. 49 into 5 is 245. Minus 251 by 49. Point Q we get. Now find out PQ. PQ is root of, apply distance formula. Point Q here, point P is here. 145 by 49 minus 1. Correct? That will be 145 minus 49. 96 by 49 square. X2 minus x1 whole square. Correct? 96 by 49 square. 96 divided by 49 the whole square. Plus 144 by 49 minus 2. 98. 49 to the 98. 98 means it becomes 46. Correct? 46 by 49 the whole square. 46 divided by 49 the whole square. Minus 49 into 4, 196. Minus 51. Minus into minus will be plus. Correct? Minus 251 plus 196. Minus 55 by 49 the whole square. Minus 55 divided by 49 the whole square. 96 square, 46 square, 55 square, 49 square. Root of 49 square is 49. Denominator will be 49. So, and then it can be option C or D, I can conclude from here. And numerator is root of 96 square plus 46 square plus 55 square. 96 square, lot of calculations involved here. 96 square is how much? 96 into 96. 6 into 6, 36. 96 into 6. 54, 57, 576. 6 into 9 is 54, 5 carry, 81, 86. Correct, no, 9 6 are 54, 5 carry, 6. This will be 6, 7 plus 4, 11, 1 carry, 6 plus 6, 12, 8, 9 to 1, 6. 46 square is how much? 46 into 46. 6 into 4, 24. 6 into 4, 24 plus 2, 26. 264. 46 into 4, 92 plus 92, 184. Right now 46. 46 into 6 is 264. 46 into 4 is 184. 46 into 4 is how much? 1 6 into 4 is 24, 2 carry, 4 4 is 16 plus 2 18, 184. 46, 6 into 6, 36, 3 carry, sorry, this is 276 actually. (46 into 46), 6 into 6, 36, 3 carry, 4 into 6, 24 plus 3, 27, 6 into 4, 24, 18, this is 6, 11, 8 plus 3, 11, 2, 1, 1, 6. 6, 11, 8 plus 3, 11, 2, 1, 1, 6. 2, 1, 1, 6. And what about 55 square? 55 square is 55 into 55. 55 into 5 is 275. 275. If I add this 5, 12, 3 plus 7, 10, 3025. 3025. 6 plus 6, 12 plus 5, 17, 2, 3, 4, 5, 3, 9 plus 4, 14, correct? 14,357 I'm getting. Root of 14,357 divided by root of 49 square is 49. I can cancel with 49 table, you can check. 49 into 2 is 98. 49 into 5 is 4, 5 remains. 49 into 2s are, if you cancel with the 7 table, the 7 table is possible. If it goes inside the root only, 14357 divided by 49 into 49, because this 49 goes inside, correct? You can cancel with the 7 table. 7 7s are, correct? 7 2s are, 7 2s are 14. 7 2s are 14. 7 2051 I'm getting. 2051. 2051, I'll write here. I'll write the answer here. Root of, with 7 table if you cancel, 7 2s are 14, 0, 7 5s are 35, 1 divided by 7 into 49, because I'm cancelling with 7 table. This is root of 7 1s are, 7 2s are 14, 6 carry, 6 carry. So 7 9s are 63, 2 carry, 7 3s are divided by 49. So this is root of 293 divided by, this 7 has been cancelled, root 49 is 7. So root of 293 by 7, option B is answer. Please make a note. Finding the distance of the point to the line. Root of 293 divided by 7. Lot of calculations involved here. Move on to the next one. Here also the same type of question is asked. Distance of the point from the line. Question asked in the year 2019. The point is given and the line is given here. The point is 1, 2, 1. I'll use the shortcut method here. The point P is 1, 2, 1 and the line is given as x minus 1 divided by 1 is equal to y minus 2 divided by 1 is equal to z minus 3 divided by 2. Okay, my vector B is going to be denominator direction ratios 2, 1, 2. So this is 2. X minus 1 by 2 is equal to y minus 2 by 1 equal to z minus 3 by 2. So this is 2i plus j plus 2k. And the point Q is, point A is required here according to my notation. Point A is required. Point A is 1 comma 2 comma 3 passing through the point 1 to 3. So vector AP we can find out. Vector AP is OP minus OA. 1 minus 1 0, 2 minus 2 0, 1 minus 3 minus 2. Right, no? AP is OP minus OA. 1 minus 1 0, 2 minus 2 0, 1 minus 3 minus 2. Now find out AP cross B. AP cross B. Vector AP cross vector B is equal to determinant of I, J, K. AP is here 0, 0, minus 2. Vector B is here 2, comma 1, comma 2. Correct? So find out the determinant of this AP cross B. I need to find magnitude of this after finding the vector. I cap in leaving first column first row. 0 minus minus 2 plus 2 minus j capital leaving second column first row. 0 minus of minus 4 plus 4 plus k cap into leaving this 0 minus 0, that is 0. Correct, no? 0 minus minus 2 plus 2 minus j cap into 0 minus of minus 4 plus 4. Find out the magnitude of this. Magnitude of AP cross B. AP cross B magnitude is what? Root of 2 square 4 minus 4 square 16. This is root 20 I am getting. Root 20 is root of 4 into 5, which is 2 root 5. Therefore, distance formula is magnitude of AP cross B divided by magnitude of vector B, which is 2 root 5 AP cross B magnitude divided by magnitude of vector B. Vector B is here. You can find out the magnitude of this. Magnitude of vector B from this. What is magnitude of vector B? That is root of 2 square is 4 plus 1 square is 1 plus 2 square is 4. Root 9 is 3. 2 root 5 divided by 3, which is option D. Please make a note of this. Using the time saving result I have solved this, not by the traditional method. Move on to the next one. Here also one more question we have of this type. Finding the distance of the point to the line. Here also I will do the time saving result only. The point P is given. The point P is this. Minus 2 comma 4 comma minus 5. Minus 2 comma 4 comma minus 5. And the line is here. X plus 3 divided by 3 is equal to y minus 4 divided by 5. Y minus 4 divided by 5 is equal to z plus 8 divided by 6. My vector B is 3i plus 5j plus 6k. Vector B is 3i plus 5j plus 6k. Vector B is here 3i plus 5j plus 6k. And point A is this. The line is passing through the point minus 3, 4, minus 8. Minus 3, comma 4, comma minus 8. Line is passing through the point minus 3, 4, minus 8. Find out vector AP. Vector AP is OP minus OA. Minus 2, minus of minus 3. Minus 2 plus 3, which is 1. 4 minus 4, 0. Minus 5 plus 8, 3. Correct? Given point is P, minus 2, comma 4, comma minus 5. Line is passing through the point minus 3, 4, minus 8. Find out AP cross B. Also we can find magnitude of vector B here only. Magnitude of vector B is root of 3 square 9, 5 square 25, 6 square is 36, which is root 70. AP cross B find out. AP cross B is determinant of I cap, J cap, K cap. AP is 1, 0, 3 and the point vector B is 3, 5, 6. 3, 5, 6. Correct? Expand this determinant. I cap into leaving first column, first row. 0 minus 15 minus 15 minus J cap into leaving second column, first row. 6 into 1, 6 minus 9. 6 minus 9 is minus 3 plus K cap into leaving third column, first row. 5 into 1, 5 minus 0. I cap into 0 minus 15 minus J cap into 6 minus 9 minus 3. Correct? So find out the magnitude here. You can take 3 common. So what remains is minus 5i plus, sorry, can't take 3 common. It's not common here, sorry. Find out the magnitude of this now. Magnitude of AP cross B. Magnitude of this root of minus 15 square is 225 plus 3 square is 9. 5 square is 25. This is how much? Root of, correct no? 0 minus 15 minus 15. 6 minus 9 minus 3. 5 minus 0. 5 square is 25. This will be 234 plus 25. 259 I am getting. Root of 259. Required formula is what? D is equal to magnitude of AP cross B divided by magnitude of vector B. This is root of 259 by root 70. Root of 259 divided by root 70. You can cancel with the 7 table. 7 3s are 21, 4 carry, 7 7s are 49, correct? Divided by 7 10s are root of 37 by 10. Option B is answer. Please make a note of this. Question asked in the year 2017. On to the next one. The image of the point in the line. Image of the point 1, 6, 3 in this line you have to find out. So the point is given. You can go by finding the foot of the perpendicular first. Point P is given as 1, 6, 3. 1, 6, 3. And the line is here. X by 1 is equal to y minus 1 divided by 2 is equal to z minus 2 divided by 3. Take this as lambda. Find out the foot of the perpendicular, point Q. From this we get x is equal to lambda, y is equal to 2 lambda plus 1, z is equal to 3 lambda plus 2. Point Q is the foot of the perpendicular, lambda, 2 lambda plus 1, 3 lambda plus 2. Find the direction ratios of PQ. PQ is perpendicular to this line L. Okay. Direction ratios of PQ are x2 minus x1, lambda minus 1, 2 lambda plus 1 minus 6, 2 lambda minus 5, 3 lambda plus 2 minus 3, which is 3 lambda minus 1. Correct? X2 minus x1, y2 minus y1, z2 minus z1. PQ is perpendicular to the line. PQ is perpendicular to the line. Implies A1, A2 plus B1, B2 plus C1, C2, 0. 1 into lambda minus 1. That is lambda minus 1. Correct? 1 into lambda minus 1. Direction ratios of this line are 1, 2, 3. 1 into this plus 2 into this plus 3 into this. This is A1, B1, C1, A2, B2, C2, or A1, B1, C1, A2, B2, C2. 2 lambda minus 1 into 1 plus 2 into 2 lambda minus 5 plus 3 into 3 lambda minus 1 is equal to 0. A1, A2 plus B1, B2 plus C1, C2 equal to 0. Correct? From this, what we get? Lambda minus 1 plus 4 lambda minus 10 plus 9 lambda minus 3 equal to 0. 9 plus 4, 13 plus 1, 14 lambda is equal to 14. We get lambda equal to 1. Once we get lambda value, I can substitute in Q. Therefore, my point Q becomes the foot of the perpendicular is lambda is equal to 1. We can substitute 1, 2 into 1, 2 plus 1, 3, 3 into 1, 3 plus 2, 5. I'll get 1, 3, 5. Putting lambda equal to 1 in this. I get the foot of the perpendicular. Once I get foot of the perpendicular, my aim is to find image. Image is also called the reflection. So point Q is the foot of the perpendicular. I am using the Q as the midpoint of the given point and the image point. Let R be the image point. Let R alpha, beta, gamma be the image. Let R alpha, beta, gamma be the image of the point P, okay, with respect to the given line. So Q is going to be the midpoint. Q is midpoint of PR it becomes. Q is the midpoint of PR. Q happens to be the midpoint of P and R. So Q is already we know, the foot of the perpendicular we know, 1, 3, 5. So 1, 3, 5 is equal to midpoint of PR, 1 plus alpha by 2, 6 plus beta by 2, 3 plus gamma by 2. Apply midpoint formula. 1 plus alpha divided by 2, 6 plus beta divided by 2, 3 plus gamma divided by 2. Correct? Midpoint formula. 1 plus alpha by 2, 6 plus beta by 2, 3 plus gamma by 2. So what do you get? Cross multiply. 2 is equal to, equate the corresponding coordinates. 1 into 2, 2 is equal to 1 plus alpha. Correct? 2 into 3, 6 is equal to 6 plus beta. 2 into 5, 10 is equal to 3 plus gamma. This gives alpha equal to 1, beta equal to 0, and gamma equal to 7. Correct? 1, 0, 7, the image of the point with respect to the given line. So 1, 0, 7 is the image. Please make a note of finding image of a point with respect to a given line. Quite important. Even for JEE exams, questions are asked based on this. Move on to the next one. Next we have coplanar lines. Two lines are coplanar means the condition for that is this. The lines are given in the Cartesian form. X minus x1 by a1 equal to y minus y1 by b1 equal to z minus z1 by c1. Another line L2 is given in this form. X minus x2 by a2 equal to y minus y2 by b2 equal to z minus z2 by c2. Lines are coplanar means determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 equal to 0. Condition for two lines to be coplanar. Please learn this condition. Questions can be asked for competitive exams on this. One such question is found here, 2014 in the CET exam. They asked the lines are coplanar. See that the lines are in the standard form. Standard form is the coefficient of x, y, z should be 1. X, Y, Z coefficient is 1. Identify A1, B1, C1, A2, B2, C2. Correct? This is X1, Y1, Z1, X2, Y2, Z2. Compare the given lines with X minus X1 by A1 equal to Y minus Y1 by B1 equal to Z minus Z1 by C1. Here, I'll write down the values of A1, B1, C1 first. Here, A1 is equal to 1, B1 is equal to 1, C1 is equal to minus K. Correct? A1, B1, C1, A2, B2, C2. A2 is K, A2 is K, B2 is 2, C2 is 1, X1, Y1, Z1. X1 is 2, Y1 is 3, Z1 is 4, X2, Y2, Z2. X2 is 1, Y2 is 4, Z2 is 5. Find out X2 minus X1. X2 minus X1 is 1 minus 2 minus 1. Y2 minus Y1, which is 4 minus 3, 1. Z2 minus Z1, 5 minus 4, 1. Correct? Condition for lines to be coplanar. Coplanar lines implies determinant of X2 minus X1, Y2 minus Y1, Z2 minus Z1. Here it is A1, B1, C1, A2, B2, C2 equal to 0. Determinant of this equal to 0. Determinant of X2 minus X1 is minus 1, Y2 minus Y1 is 1, Z2 minus Z1 is 1, A1, B1, C1, 1, 1 minus K, A2, B2, C2, K, 2, 1 is equal to 0. Correct? Expand this. Minus 1 into, leaving first column, first row. 1 plus 2K, 1 plus 2K, minus 1 into, leaving second column, first row. 1 into 1, 1 plus K square, plus 1 into, leaving third column, first row. 2 minus K. Minus 1 into, leaving first column, first row. 1 plus 2K, minus 1 into 1 plus K square, plus 1 into 2 minus K. This is minus 1, minus 2K, minus 1, minus K square, plus 2, minus K equal to 0. Correct, no? From this minus K square, minus 1, minus 2 plus 2 will cancel. These terms will add up to 0. Minus 1, minus 2 plus 2, 0. What we get is minus K square, minus 2K, minus K, minus 3K equal to 0. Can take minus K common here. So what it means is K plus 3 equal to 0. Minus K equal to 0 implies K equal to 0 or K equal to minus 3. Correct? Minus K is taken common. K equal to 0 is also found here. K equal to minus 3 is not found. K equal to minus 3 not given. K equal to 0 is the answer. K is either 0 or minus 3. Anyway, minus 3 is not found. K equal to 0 is found in the options. Correct? So minus K is taken common. K plus 3 remains. A into B 0 means either A equal to 0 or B equal to 0. So K equal to 0 or K plus 3 0 gives K equal to minus 3. Minus 3 is not found, but K equal to 0 is found. Question asked in the year 2014. I think with this we completed lines part. Now I'm going to the equation of plane here. Okay, equation of plane here, what we can, this part is a deleted part actually from the NCERT textbook. This is not there for KCET and even for JEE main. JEE advanced the questions can be asked. Even for other competitive exams like NDA or NA, such exams questions can be asked for equation of planes and concept of plane. Okay, so we have different forms of plane. The first one is the normal form. So normal form is this vector equation r dot n cap is equal to d. D is the distance of the plane from the origin. N cap is unit normal vector to the plane. A normal vector is drawn from the origin to the plane Okay, normal vector means vector which is perpendicular to the plane. Vector which is perpendicular to the plane is called as normal to the plane. So n cap is unit normal vector. N cap is unit normal vector. Normal to the plane means line which is perpendicular to the unit normal vector to the plane I can call. N cap is the unit normal vector. N cap is unit normal vector to the plane. Okay. D is the distance of the plane from the origin. D is the distance of the plane from the origin. And the Cartesian form is this: Lx plus My plus Nz equal to D. The Cartesian form. Vector form is this: unit normal vector to the plane. N cap is unit normal vector. D is the distance of the plane from the origin. So normal vector is drawn from the origin to the plane. In that case, we can find the equation of the plane in the normal form. Okay, unit normal vector to the plane drawn from the origin. It is from the origin. Normal vector is drawn from where? From the origin. Something like this. Normal to the plane. Normal is drawn from the origin to the plane. Plane is here. Okay. D is the distance of the plane from the origin. N cap is the unit normal vector to the plane. N cap is unit normal vector to the plane. D is the distance of the plane from the origin. This is the formula. There is one question asked on this. We have also given some note of this. The coefficients of x, y, z will give the direction ratios of normal to the plane. Normal means a line which is perpendicular to the plane. So coefficients of x, y, z, which is a, b, c here, are the direction ratios of normal to the plane. And direction cosines of the normal vector is same as the direction ratios of the corresponding unit normal vector. Unit normal vector means vector divided by its magnitude. Normal vector, when you divide by magnitude, it becomes unit normal vector. For unit normal vector, what is direction ratios? That is same as direction cosines of the normal vector. And the coordinates of the foot of the perpendicular drawn from origin to the plane is this: LD, MD, ND. If the plane takes this form, okay. This I'll be using later. I'll tell you later about this. There are questions, a few questions asked based on this. Now I'll take the problems connected to this normal form of the plane. The first one is called as normal form of a plane. Normal is drawn from the origin to the plane. Normal means a line which is perpendicular to the plane. A line which is perpendicular to the plane is called as normal to the plane. So if you know the distance of the plane from the origin and if you know the unit normal vector, we can use this. The normal form is applicable if you know two things. One is distance of the plane from the origin, and also you must know the n cap. N cap is unit normal vector to the plane from the origin. Two things you should know. Here in this question they asked to find the equation of the plane, which is at distance of 3 by root 14 from the origin. So distance of the plane from the origin is given. D is equal to 3 by root 14. Distance is given, and also they given the normal from the origin. So normal vector is given from the origin. I should make it unit normal vector. N vector I'll write first. N vector, this is a normal vector, is given as 2i minus 3j plus k. Normal vector is given. From this you find unit normal vector n cap. N cap is equal to vector n divided by magnitude of vector n, which is 2i minus 3j plus k divided by magnitude of this how much? Root of 2 square 4 minus 3 square 9, 1 square 1. Normal vector divided by its magnitude gives unit normal vector dividing by magnitude of this, correct? So what you get is 2i minus 3j plus k cap divided by root 14. So equation of the plane is r dot n cap equal to d. Equation of the plane is r dot n cap equal to d. R dot n cap is equal to d, which is vector r dot n cap is here 2i minus 3j plus k divided by root 29 is equal to distance of the plane from the origin is 3 by root 14. Sorry, root 14, no, sorry. root 14. Sorry. 3 by root 14. So root 14 is going to cancel. Root 14 cancels on either side. So what you get is r dot 2I minus 3j plus k is equal to 3. Root 14 is going to cancel. R dot 2I minus 3j plus k equal to 3, which is option B. So this is a normal form of the plane. Distance of the plane from the origin is given and normal vector from the origin is given. Correct? Normal from the origin is given. Two things are given. Then you can use normal form. One is distance of the plane from the origin and also the normal vector from the origin to the plane is given. From the normal vector we find unit normal vector. Normal vector divided by its magnitude gives unit normal vector. N cap is unit normal vector. R dot n cap is equal to D. D is 3 by root 14. Root 14 cancels. So you get R dot 2I minus 3j plus k equal to 3. Question asked in the year 2016. Next we have the second form of the plane passing through the point and perpendicular to given vector. So plane is passing through some point whose position vector is vector A and it is perpendicular to n vector. In that case we have r minus a dot n vector equal to 0. That is vector form. This is Cartesian form. A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. According to this, the plane is passing through the point x1, y1, z1 and it is perpendicular to the line whose direction ratios are a, b, c. Capital letters a, b, c, no? The direction ratios of the normal to the plane. The plane is passing through the point x1, y1, z1 and it is perpendicular to the vector whose direction ratios are a, b, c. So perpendicular vector is normal to the plane. So there are a few questions based on this. We have equation of the plane perpendicular to this line and passing through this point. So plane is passing through the point 2, 3, 4. Of course, all the options are in terms of Cartesian form. So we'll use the Cartesian form. The point is 2, 3, 4. Point is 2, 3, 4. This is x1, y1, z1. Okay, passing through this point. And the plane is perpendicular to this line. The line has direction ratios 1, 2, 3, correct? So here A is 1, B is 2 and C is 3. A is 1, B is 2, C is 3. The line is, plane is perpendicular to the line. Line has direction ratios proportional to 1, 2, 3. That is A, B, C, correct? Direction ratios of normal. Normal means a vector which is perpendicular to the plane. So the plane is perpendicular to this line. Line has direction ratios 1, 2, 3. That is A, B, C. So equation of plane we can write down. Equation of the plane is A into x minus x1 plus B into y minus y1 plus C into z minus z1. A into x minus x1 plus B into y minus y1 plus C into z minus z1 is equal to 0. A is 1. 1 into x minus x1 is 2. B is 2. 2 into y minus y1 is 3. C is 3 into z minus z1 is 4 equal to 0. Simplify this, get the answer. X plus 2y plus 3z, correct? This is minus 6 minus 2 minus 8 minus 8 minus 12 minus 20 equal to 20. X plus 2y plus 3z equal 20. Question asked in the year 2014. Plane is passing through the point and it is perpendicular to the line. So perpendicular to the line, denominator is direction ratios A, B, C. A, B, C are direction ratios of the normal to the plane. Normal means a line which is perpendicular to the plane. So point is x1, y1, z1. I substitute for x1, 2, y1, 3 and z1, 4. A, B, C. That is 1, 2, 3. X plus 2y plus 3z. Minus 2 minus 6 minus 8 minus 12 minus 12 minus 12 minus 20 minus 6 minus 12 minus 18 minus 2 minus 20 equal to 20 equal to 0. Move on to the next one. We have the plane which is passing through containing the point and the line. Question asked in the 2024. Plane is containing this point and the line. There is some plane, okay, which contains the point and the line. Is going to contain the point 3, 2, 0, 3, 2, 0, and the line is this: x minus 3 by 1 equal to y minus 6 by 5 equal to z minus 4 by 4. Line is there and the point is there. The plane is containing this point and the line. Correct? Point is this, line is this. So equation of this line is given. This line is passing through the point 3, 6, 4, correct? So this line is given: x minus 3 divided by 1 is equal to y minus 6 divided by 5 is equal to z minus 4 divided by 4. That means this point, I'll take it as A here. A is this point. This point B, the line is also passing through the point 3, 6, 4. Line passes through the point. This line is passing through the point 3, 6, 4. Correct? So I can construct on vector AB there. Okay? And AB is a line along the plane. What is AB? The line AB is the vector AB I can write. Correct? 3 minus 3, which is 0. 6 minus 2, 4. 4 minus 0, 4. AB. AB is a line along the plane. And line is already given to us. So direction ratios are proportional to 1, 5, 4. So if you take the cross product of AB vector and the line, we'll get the cross product of those two will be a line which is perpendicular to the plane of those, plane containing those lines. So I'll get AB cross L. This line I'll call it as L. So AB cross L will be the cross product of these two, which is perpendicular to the plane. Correct? That is the direction ratios of the normal vector I'm getting. AB is what? 0, 4, 4. The line L is what? 1, 5, 4. Expand this. What we get? I cap into, leaving first column first row. 4 into 4, 16. 16 minus 20. 16 minus 20, which is minus 4. Minus J cap into, leaving second column first row. 0 minus 4, minus 4. Plus K cap into 0 minus 4, minus 4. Correct? Leaving first column first row. 16 minus 20, minus 4. Minus J cap into 0 minus 4, minus 4. K cap into 0 minus 4, minus 4. Direction ratios will be what? Proportional to, if you divide by minus 4 and write, it will be 1, minus 1 and 1. Correct? Dividing by minus 4 and writing. This is the direction ratios of normal to the plane, because A cross B is a vector perpendicular to both A and B. So AB cross L is a vector, is perpendicular to vector AB and also perpendicular to L. L is a line along the plane. AB is a vector along the plane. So cross product of those two will be a vector perpendicular to the plane, which is the normal to the plane. So this is direction ratios of normal to the plane. These are direction ratios of normal to the plane. The cross product gives direction ratios of normal to the plane. And the plane is passing through the point 3, 2, 0. It also passes through the point 3, 6, 4. Any point we can take. We can take the equation of plane in this form now. A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. ABC is this 1 minus 1 1. This is ABC. Direction ratios of the normal to the plane. So 1 into x minus, it is passing through 3, 2, 0. No, I can take that point. Minus 1 into y minus 2. And c is 1 into z minus 0 is equal to 0. Can write this as x minus y plus z minus 3 plus 2, which is minus 1 equal to 0. X minus y plus z equal to 1. This is option A. Can rewrite this as x minus y plus z equal to 1. Please make a note of this. Finding the equation of the plane which is passing through the point and it is containing the line, containing the point and the line. We can construct a vector which is lying along the plane. Already one line is there, and I can construct another line because it is containing these points, and also this line is passing through the point 3, 6, 4. Correct? Using those two, I could get a vector AB which is 0, 4, 4, and take the cross product of 0, 4, 4, which is direction ratios of AB, and direction ratio of L, which is 1, 5, 4. Cross product will give this, correct? 0 I cap into 16 minus 20 minus 4 minus j cap into 0 minus 4 minus 4 k cap into 0 minus 4 minus 4. Divide by minus 4, I can write 1 minus 1 as direction ratios of normal to the plane. So equation of plane I can write. I can take either the point 3, 6, 4 also. If you want, I can take, see, 1 into x minus 3 minus 1 into y minus 6, z is 1 into z minus 4 equal to 0. We'll get the same answer. Passing through the point, I can take either 3, 6, 4 or 3, 2, 0. Any point is okay. We'll get the same answer. X minus y plus z here plus 6 minus 3 minus 4 minus 7 plus 6 is minus 1 equal to 0 equal to 1 again. Same answer. X minus y plus z equal to 1. Please make a note of this. Finding the equation of the plane. Move on to the next one. Two comma 3 comma minus 1 is the foot of the perpendicular from the point to the plane. Then the equation of the plane you have to find out. Question asked there 2023. So foot of the perpendicular is given. 2 comma 3 comma minus 1 is foot of the perpendicular from this point to the plane. So from the point 4 comma 2 comma 1, a perpendicular is drawn. This is the foot of the perpendicular. Correct? This is a point on the plane, I can tell. Plane is passing through this point because this is the foot of the perpendicular, means something like this. 2 comma 3 comma minus 1 is the foot of the perpendicular. Okay, from the point 4 comma 2 comma 1. From the point 4 comma 2 comma 1, the perpendicular is drawn. Correct? Perpendicular is drawn from the point 4 comma 2 comma 1 to the plane. So I can find out the direction ratios of this vector, which is the normal to the plane. Because it's a perpendicular, it is a normal to the plane, and the plane is passing through the point 2 comma 3 comma minus 1. Because the foot of the perpendicular means that point lies on the plane. So plane is passing to the point 2 comma 3 comma minus 1. Plane passes through the point 2 comma 3 comma minus 1. Plane is passing through this point 2 comma 3 comma minus 1. And direction ratios of normal to the plane are direction ratios of normal to the plane. Direction ratios of normal to the plane are direction ratios of normal we can find out. X2 minus x1, 4 minus 2 is 2, 2 minus 3 is minus 1. This is a normal vector. I'm finding direction ratios of lines joining 2 points. X2 minus x1, y2 minus y1, z2 minus z1, 4 minus 2 is 2, 2 minus 3 is minus 1, 1 minus minus 1 is 2. Correct? 2 minus 1, 2, 4 minus 2, 2, 2 minus 3 is minus 1, 1 minus minus 1 is plus 1, 1 plus 1, 2. This is ABC. ABC is this. This is the point x1, y1, z1. Therefore, equation of the plane is A into x minus x1 plus B into y minus y1 plus C into z minus z1 equal to 0. That is 2 into x minus 2 minus 1 into y minus 3 2 into z minus minus 1 equal to 0. What do you get? 2x minus y plus 2z here minus 4 plus 3, which is minus 1, minus 1 plus 2. This is minus 4 plus 3 plus 2. 3 plus 2, 5. 5 minus 4 is 1 equal to 0. 2x minus 5 plus 2z plus 1 equal to 0. This is option B. 2x minus 5 plus 2z plus 1 equal to 0. Plane is, equation of the plane is this. Please make a note. Question asked in the year 2023. On to the next one. Equation of plane passing through the three non-collinear points we have in the vector equation, vector form. It's a box product of r minus a, b minus a, c minus a equals 0. Or in the Cartesian form we have determinant of x minus x1, y minus y1, z minus z1. Second row, x2 minus x1, y2 minus y1, z2 minus z1. Third row, x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. Okay, please learn this. Plane passing through three non-collinear points. We have one question based on this asked in the year 2023. Plane is passing through 3 points. So take this point as x1, y1, z1, x2, y2, z2, x3, y3, z3. Okay. So the first point A I'll call x1, y1, z1. This is 2, 1, 0. This is point B is here. Point B is 3, 2, minus 2. Point C is 3, 1, 7. x1, y1, z1, x2, y2, z2, x3, y3, z3. Correct? This is the point A. This is x1, y1, z1. This is the point B, which is x2, y2, z2. This is x3, y3, z3. Plane is, equation of the plane is, equation of the plane is determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. Determinant of x minus x1 is 2, y minus y1 is 1, z minus z1 is 0 equal to 0. Correct? x1, y1, z1, 2, 1, 0. x2 minus x1, 3 minus 2 is 1. x2 minus x1, y2 minus y1, 2 minus 1 is 1, z2 minus z1, minus 2 minus 0, minus 2, x2 minus x1, y2 minus y1, z2 minus z1. Next row is x3 minus x1, 3 minus 2 is 1, 1 minus 1, 0, 7 minus 0 is 7, x2 minus x1, y2 minus y1, z2 minus z1. Correct, no? 3 minus 2, 1, 2 minus 1, 1, minus 2 minus 0, 1. x3 minus x1, 3 minus 2, 1, 1 minus 1, 0, 7 minus 0, 7. Expand this. X minus 2 into, leaving first column, first row. 7 minus 0, 7. Minus y minus 1 into, leaving second column, first row. 7 plus 2, 9. Plus z minus 0 is z, leaving third column, first row. 0 minus 1 equal to 0. This is 7x minus 14 minus 9y plus 9 minus z equal to 0. Seven x minus 9y minus z minus 5, that is equal to 5. 7x minus 9y minus z equal to 5, or minus 5 equal to 0 we can write. Minus 5 equal to 0 as given in the options. Plane passing through the 3 non-collinear points. Answer is option A. Please make a note of this. On the next one. Intercept form, we have the plane in the intercept form x by a plus y by b plus z by c equal to 1. In straight lines we had intercept form, correct? 2D geometry, x by a plus y by b equal to an equation of line there. It's equation of plane where a, b, c are intercepts, x intercept, y intercept and z intercept. That means the plane passes through the point a comma 0 comma 0 and 0 comma 0 comma b comma 0 and 0 comma 0 comma c. Plane is passing through the point a comma 0 comma 0, 0 comma b comma 0, 0 comma 0 comma c. That's x intercept is a, y intercept is b and z intercept is c. Equation of the plane is in this form. Then centroid of the triangle formed by this is a by 3, b by 3, c by 3. Clearly we know that x by a plus y by b plus z by c equal to 1 is a plane passing through 3 points a comma 0 comma 0, 0 comma b comma 0, 0 comma 0 comma c. Centroid of the triangle formed is this a by 3, b by 3, c by 3. Just apply the formula for centroid x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. We'll get this. And one more result I given here. If the plane meets the coordinate axis at ABC such that centroid of the triangle ABC is ABC, then the equation of the plane becomes x by a plus y by b plus z by c equal to 3 it becomes. Centroid of the triangle is ABC. Suppose alpha, beta, gamma are the x-intercept, y-intercept and z-intercept. So they told centroid of the triangle ABC, the plane is meeting the coordinate axis at ABC. So point A will be alpha 0 0, okay, point B will be 0 beta 0 where it meets the y-axis, where it meets the z-axis is 0 0 gamma. Centroid of the triangle is given to be equal to ABC, okay. In that case centroid ABC is equal to, if you apply centroid of this triangle, it becomes alpha plus 0 by 3, 0 plus beta plus 0 by 3, 0 plus 0 plus gamma by 3. Apply centroid formula for this coordinates ABC. You get alpha by 3, beta by 3, gamma by 3, correct? Centroid is alpha by 3, beta by 3, gamma by 3. And this will become alpha is equal to 3a from this. Alpha is equal to 3a, beta is equal to 3b and gamma is equal to 3c. Equation of the plane is actually x by alpha plus y by beta plus z by gamma is equal to 1. Correct? Alpha is 3a. So x by 3a plus y by beta is 3b plus z by gamma is 3c is equal to 1. You can multiply the entire equation by 3, get this. X by a plus y by b plus z by c equal to 3. Centroid of the triangle is ABC. Then the equation of the plane where the plane is making intercepts alpha, beta, gamma is given by x by a plus y by b plus z by c equal to 3. You can deduce it if the question is asked. Directly also we can do it. Okay. Questions are asked based on this. One such question is found here. Plane meets the coordinate axis at ABC in such a way that centroid of the triangle is given. Centroid of the triangle is given. Centroid of the triangle is given at this point 1, 2, 3. Equation of the plane is what? So directly we can write equation of the required plane is x by 1 plus y by 2 plus z by 3 equal to 3. Equation of the plane with centroid ABC is, with centroid ABC centroid is at ABC is x by A plus y by B plus z by C is equal to 3. Here centroid is given at 1, 2, 3. Of course, plane meets the coordinate axis at ABC. That condition should be there. Okay, in that case I'm telling. So that is equation of the plane is centroid is at 1, 2, 3. So x by 1 plus y by 2 plus z by 3 is equal to 3. That's the answer. Correct? X by 1 plus y by 2 plus, or you can multiply, you can divide by 3, entire equation. If you divide by 3, we get x by 3 plus y by 6 plus z by 9 is equal to 1. Divide the entire equation by 3. X by 3 plus y by 6 plus z by 9 equal to 1. Option B is the answer. You can reduce the method also, as I explained in the previous one. Move on to the next one. Here, the equation of the plane passing through intersection of two planes. Something like this. One plane is there, another plane is there. Two planes intersect along a line, we know. That's called as line of intersection. The open book is an example. You take an open book, okay? The first half is the first plane and second half is second plane. You can see the line of intersection. Two planes intersect along a line. So line of intersection is there. And the third plane is passing through this. Third plane is passing through the line of intersection of the two planes. Want to find the equation of that plane. First plane is r dot n1 is equal to d1. The first plane is r dot n1 is equal to d1. The first plane is vector r dot n1 is equal to d1. Second plane is r dot n2 is equal to d2. Correct? And this plane, which is passing through the line of intersection of the two planes, is given by r dot n1 plus lambda n2 equal to d1 plus lambda times d2. In the Cartesian form also we have this. The first plane is there and second plane is there. First plane plus lambda into second plane equal to 0. This is the equation of plane passing through the line of intersection of the two planes. Okay. We got one question asked in the year 2015 here. So equation of the line they ask, which is passing through this point and parallel to the line of intersection of the two planes. And if you want to find the line which is the intersection of the two planes, direction ratios of that is going to be the cross product of the two normals to the planes. That is also there. So you should take the normal to first plane, normal to second plane. Line they are asking to find the equation of line. Line is passing through 2, 3, 1. So I can write the equation of line as x minus 2 divided by y minus 3 divided by z minus 1 divided by. Line is passing through the point 2, 3, 1. And it is parallel to the line of intersection of the two planes. The two planes are intersecting along a line, we know. Correct? This is the line of intersection of the two planes. This line is the line of intersection of the two planes. This line is the line of intersection of the two planes. Correct? Two planes intersect and the third plane is passing through the line of intersection. The white one is the line of intersection of two planes. You want to find a line which is passing through this point 2, 3, 1 and it is parallel to the line of intersection. So if you want to find a line which is parallel to the line of intersection, we want to determine its direction ratios now. To find the direction ratios of the line of intersection, what I am going to do is, I am taking the cross product of the two normals. The normal to the first plane has direction ratio, normal to the plane direction ratios are nothing but the coefficient of x, y, z. Okay, so first plane is here, x minus 2y minus z plus 5 equal. What are the coefficients of x, y, z? Coefficients of x, y, z gives the direction ratios of normal to the plane. So coefficients of x, y, z are what? That is, I'll write direction ratios of the first plane. Okay, A1, B1, C1 I'll call. A1, B1 and C1. Direction ratios of normal to the first plane. 1, minus 2, minus 1. 1, minus 2, minus 1. That is direction ratios of normal to first plane. Normal means a line which is perpendicular to the plane. So one line is perpendicular to this plane. That line has direction ratios 1, minus 2, minus 1. Second plane is here. Direction ratios of normal to second plane are 1, 1, 3. Remember, coefficients of x, y, z are going to give the direction ratios of normal to the plane. That is A2, B2, C2. A2, B2, C2. Direction ratio is what? 1, 1, 3. Take the cross product of this. Cross product of these two normal vector will be the line of intersection of two planes. Will be along the line of intersection of two planes. Because cross product of two vectors is perpendicular to the plane containing those two. N1 is perpendicular to this plane. N2 is perpendicular to this plane. N1 cross N2 if you take, that will be along the line of intersection of two planes. So this is N1 actually. This is N1 and N2. N1 normal to first plane. This is normal to second plane. Okay. N1 cross N2 I am finding. N1 cross N2, which is equal to determinant of I cap, J cap, K cap. This is 1 minus 2 minus 1, 1, 1, 3. Expand this. That will give the line of intersection, direction ratios of the line which is parallel to line of intersection. That I can substitute. This is I cap into, leaving first column first row, minus 2 into 3, minus 6 plus 1, which is minus 5. Correct? Leaving first column first row, minus 2 into 3, minus 6 plus 1, minus 5. Minus J cap into, leaving second column first row, 3 plus 1, which is 4. Plus K cap into, leaving third column first row, 1 plus 2, 3. Correct? K cap into 1 plus 2, 3. I cap into minus 6 plus 1, minus 5. Minus J cap into 3 plus 1, 4. Correct? So it's parallel to the line having direction ratios. Line of intersection is parallel to the line whose direction ratios are proportional to minus 5, minus 4 and 3. Or else if you want, you can multiply by minus 1 if it is not found in the options exactly. Minus 5, minus 4, 3 is present. X minus 2 by minus 5, y minus 3 by minus 4, z minus 1 by 3. It is found here in option B. Correct? Option B is the answer. Please make a note of this. On to the next one. Next we have angle between the line and the plane. It is defined as angle between the normals. Angle between the line and the normal to the plane. Angle between the line and the plane is defined as line is this, plane is this. If you want to find angle between the line and the plane, what you do is find angle between the line and normal to the plane. Normal means perpendicular to the plane. Draw one perpendicular, okay, and line. So normal means a line which is perpendicular to the plane, okay, and you take another vector which is a given line. Angle between the line and the plane is going to be angle between the two normals. You can take this example. You want to understand angle between the line and the plane. My palm is plane and this is my pen is the normal to the plane. If you want to find angle between the line and the plane, first draw the normal to the plane. Okay, this is normal to the plane. And this is the line, the green one, okay, this is the line. You want to find angle between the line and the plane means you find angle between, it's defined as angle between the line and normal to the plane. Normal is the pen, okay, black one is the normal, green one is line, like this. So line and plane, if you want to find out angle, find the angle between the line and normal to the plane, okay. So that's a definition. And that's a complement of, it's a complement of is 90 minus we should find out. 90 minus angle between the line and the normal to the plane, 90 minus theta. Suppose theta is the angle between the line and the normal, 90 minus that will give the angle between the line and the plane. That means this angle you find out. Angle between the line and the plane you find out. Angle between the black pen and the green one, okay, find out. 90 minus of that will give this angle. This angle you get. This angle between the line and the plane. Okay. Angle between the line and the plane is defined as complement of, means 90 minus angle between the line and normal to the plane. Normal means a perpendicular to the plane. Draw the perpendicular to the plane, that is normal. Line is given to us. Find out this angle. Angle between green and black pen, find out. Okay, that is theta. 90 minus theta gives the angle between the line and the normal to the plane. There are formulas also. Sine inverse of mod of n dot b by magnitude of n, magnitude of b. N vector is normal to the plane. Equation of plane is given, equation of line is given. For us, in the equation of line, what is important is vector b, because line L is passing through the point whose position vector is vector a and parallel to vector b, and this is normal to the plane. Plane is given like this. N vector is the normal to the plane. N vector is normal to the plane. So for us, what is important is the normal vector and vector b, because line is passing through the point whose position vector is vector a and parallel to vector b. So vector b is important and normal vector is important. If you find angle between those two, you'll get in terms of cos inverse 90 minus the cos theta. I'll get first. Cos theta is actually cos theta. Cos theta is equal to n vector dot b divided by magnitude of n into magnitude of b. Like this we get. Cos theta we get. Okay. Cos theta. Then find out phi is equal to 90 minus. Phi is 90 minus theta. So if you apply sine function on both sides, sine phi is equal to sine of 90 minus theta. I am getting. Sine of 90 minus theta is equal to cos theta. Cos theta is here, correct? Cos theta is mod of n dot b divided by magnitude of n into magnitude of vector b, sin phi, or phi is equal to sine inverse of, phi is equal to sine inverse of mod of n dot b divided by magnitude of vector n into magnitude of vector b. This is the formula to find the angle between the line and the plane. Is defined as complement of angle between the line and normal to the plane. Normal to plane and line, you find out the angle theta. 90 minus theta gives angle between the line and the plane, which is called as phi, taking sine function on both sides and write phi as sine inverse of. And in the Cartesian form also given, line is in the form of x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c, and the plane is given like this. Phi is equal to sine inverse of AA plus BB plus CC by root of A square plus B square plus C square, root of A square plus B square plus C square, angle between the line and the plane. Okay, so quite important formula. It's deleted part, still I'm doing it all these things because one or the other exam it might be useful. So see that the line and plane are in the standard form. Line is in the standard form, means coefficient of x, y, z should be 1 here. Okay, so here coefficient of x 1 here, y is 1, z is not 1. Rewrite this because coefficient of z is negative here, minus z. So rewrite this equation. How to write this equation? Given line is x minus 2 divided by 3 is equal to y minus 3 by 4. For the third part, that is z part, you multiply by minus 1 for numerator denominator, or else minus 5 is there. You make it plus 5, absorb the negative sign of denominator to numerator. So minus you multiply to numerator becomes 4 minus z becomes z minus 4. Z minus 4 divided by 5. Okay, the plane is here, the line is here and the plane is here. So from the line we get small ABC. Correct, this is small ABC. And coefficient of x, y, z will give the direction ratios of normal to the plane, which is capital ABC. Capital ABC we know. Capital A is equal to 2. Capital B is equal to minus 2, capital C is 1. So sine of the angle between the two, sine phi is equal to mod of formula AA plus BB plus CC divided by root of what we have is A square plus B square plus C square into square root of A square plus B square plus C square. This is equal to mod of AA multiply 3 into 2, 6, 3 into 2, 4 into minus 2, minus 8, plus 5 into 1, 5, divided by root of A square plus B square plus C square, 3 square 9, 4 square 16, 5 square 25, root of 2 square 4, minus 2 square 4, 1 square 1. 6 plus 5, 11. 11 minus 8, which is 3. correct? Divided by, this is root 50, and this is root 9. Root 9 is 3, 3 cancels. We get 1 by root 50. Root 50 is root of 25 into 2, which is 5 root 2. 1 by 5 root 2. This is sine phi. Sine phi is this. You want to find phi. Phi is the angle, no? So phi is equal to sine inverse of 1 by 5 root 2. Which is option A. Question asked in the year 2024. Angle between line and the plane. Please make a note. Move on to the next one. Acute angle between the line and the plane. Same concept. So line is in the standard form because coefficient of x, y, z all 1 here. So denominators are small letters a, b, c, correct? X minus 5 by a, x minus x1 by a, equal to y minus y1 by b, equal to z minus z1 by c. Denominators are small letters a, b, c. So a, b, c I can write from this. A is equal to 2. B is equal to minus 1, C is equal to 1, A, B, C. Capital A is 3, capital A is 3, capital B is minus 4, capital C is minus 1, capital A, B, C is A, B, C. 3, minus 4, minus 1. Angle between line and plane. Apply the formula, get the answer. We have sine phi is equal to, the formula is sine phi is equal to mod of AA plus BB plus CC. AA plus BB plus CC. Small letter ABC are direction ratios of the line. Capital ABC are direction ratios of normal to the plane. So angle between the line and the plane, complement of that is sine inverse will get in terms of, correct? So root of A square plus B square plus C square. Root of A square plus B square plus C square into root of A square plus B square plus C square is equal to mod of AA, that is 2 into 3, 6, minus 1 into minus 4 becomes plus 4. 1 into minus 1, minus 1. Correct? AA plus BB plus CC by root of A square plus B square plus C square. Root of 2 square is 4, minus 1 square is 1, 1 square is 1. Root of 3 square is 9, minus 4 square is 16, minus 1 square is 1. 6 plus 4, 10 minus 1, 9. Divided by, this is root 6 and this is root 26. Sorry, yeah, 26, root 26. 3 square 9, minus 4 square 16, 16 plus 9, 25 plus 26. 9 by root 26 into root 6. They are given in terms of cos inverse and sin inverse, so you have to be careful here. So this is 9 by root of 26 into 6, that is 126, correct? 26 into 6 is 156. 26 into 6 is 156, which could be written as root of 4 into 39, correct? 6 plus 4, 10 minus 1, 9. 9 by root 6 into root 26. 26 into 6 is 156, which is 9 by root of 4 into 39 I can write. 4 into 39 is 156, correct? So root 4 is 2. 9 by 2 root 39 I can write. 9 by 2 root 39, which is not found in the options in terms of sine, correct? This is sine phi. You can find out cos phi. You know, cos square phi is equal to 1 minus sine square phi. Cos square phi is 1 minus sine square phi. This will be 1 minus 9 square is 81 and root 156 square is 156. So we get 156 minus 81 divided by 156. 56 plus 19, this is 75 I am getting. 75 by 156. 75 divided by 156, or cos phi is equal to root of 75 divided by root of 156, taking the positive square root. Root of 75 is root of 25 into 3, 5 root 3, and this is 2 root 39, which you can write it as 5 root 3 divided by 2 into root 39 is root 3 into root 13. So root 3 is going to cancel. I'm getting 5 by 2 root 13. 5 by 2 root 13, which is in terms of cos inverse. Cos phi, I'm getting 5 by 2 root 13, correct? No? Root 75 is root of 25 into 3, which is 5 root 3. Root 156, already simplified there, 2 root 39. Root 39 is root 3 into root 13. So root 3 cancels. 5 by 2 root 13, that is cos phi. So phi is cos inverse of 5 by 2 root 13. So phi is expressed in terms of cos inverse. Cos inverse of 5 by 2 root 13. Option A is answer. So here the answer is expressed in terms of cos inverse, not in terms of sin inverse. If you keep in terms of sin inverse, none of the options is going to match. So after finding sin phi, you find cos phi, so that we get the answer. Cos square phi is 1 minus sin square phi. From there we get the answer. Option A is answer. Question asked in there, 2019. Move on to the next one. We have the plane is making an angle sin inverse alpha with x-axis. Find the value of alpha. X-axis is after all a line, correct? Direction cosines of x-axis we know 1, 0, 0, and direction ratios are proportional to direction cosines. So I can take for x-axis, I'll take direction ratios as 1, 0, 0. For x-axis, it is a line. I'll take the direction ratios as 1, 0, 0. It's a line. And for plane, normal to the plane, direction ratios are normal to the plane has direction ratios proportional to 2 minus 3, 6. Because coefficients of x, y, z will give the direction ratios of normal to the plane. 2 minus 3, 6. Remember, whenever the equation of plane is given, coefficients of x, y, z gives direction ratios of normal to the plane. 2 minus 3, 6. And direction ratios of x-axis taken as 1, 0, 0. You know, sin alpha, apply the formula. This is small abc. Small abc. This is capital ABC according to our notation. So sin phi is equal to mod of AA plus BB plus CC divided by root of A square plus B square plus C square. Root of A square plus B square plus C square. Root of capital A square plus B square plus C square is equal to mod of 1 into 2, 2, 0 into this, 0, here 0 into 6, 0, divided by root of 1 square plus 0 square plus 0 square, 1 plus 0 plus 0, root of here 2 square, 4, plus minus 3 square, 9, 6 square is 36. So this is 2 by, this is 1. This is the root 49, which is 7. So alpha is, they told us in terms of sin inverse. So phi is sin inverse from this. Phi is sin inverse of 2 by 7. According to the question, sin inverse of alpha is the angle between x-axis and the given plane. Compare with sin inverse alpha. So we get alpha equal to 2 by 7. Question asked in there 2017. Please make a note. Move on to the next one. The sign of the angle between the line and the plane in the year 2020. Correct? This was in 2019, it's 2024, 2020 also they have one question. Sign of the angle between the line and the plane. Line should be in the standard form, means coefficient of x by z should be 1. Here coefficient of y is minus. Rewrite the equation of line first. So given line is x minus 2 divided by 3 is equal to 3 minus y by minus 4 is y minus 3 by 4. Correct? Y minus 3 divided by 4. Minus is absorbed to numerator. Y minus 3 by 4 it becomes. Correct? Z minus 4 by 5. This is A, B, C. Correct? Denominators are A, B, C. And the plane is this. 2x minus 2y plus z equal to, normal to the plane we can write. Plane is given as 2x minus 2y plus z equal to 5. Direction ratios of normal to the plane are drs of normal to the plane. Direction ratios of normal to the plane are 2, minus 2, 1. Coefficient of x, y, z are direction ratios of normal to the plane. So angle, sign of the angle between the line and the plane to find out, correct? So sin phi is equal to, apply the formula, mod of AA, this is capital ABC, direction ratios of normal to the plane, 2, minus 2, 1, coefficients of x, y, z. Coefficient of x, y, z gives direction ratios of normal to the plane. So line is here, normal to the plane is here, and apply the formula AA, 3 into 2, 6, 3 into 2, 4 into minus 2, which is minus 8, 5 into 1, 5, divided by root of 3 square 9, 4 square 16, 5 square 25, root of here 2 square 4, minus 2 square 4, 1 square 1, correct? AA, 3 into 2, 6, 4 into minus 2, minus 8, 5 into 1, 5, AA plus BB plus CC by root of 3 square 9, 4 square 16, 5 square 25, root of 2 square minus 2 square 1 square, 6 plus 5, 11 minus 8 is 3, numerator is 3, divided by root 50, that is 5 root 2, and this is root 9, which is 3, 3 cancels, you get 1 by 5 root 2. 1 by 5 root 2, we can rationalize this, multiply and divide by root 2. So this becomes root 2 divided by root 2 into root 2 is 2, 2 into 5 is 10. So phi is equal to sign of the angle they asked, that's it, that's the answer. Sin phi, sign of the angle between the line and the plane, sin phi is equal to root 2 by 10. I think this is the same question as 2024, correct? X minus 2 by 3, y minus 3 by 4, z minus 4 by 5, x minus 2 by 3, y minus 3 by 4, correct, z minus 4 by 5, 2x minus 2y plus z equal to 5. Same question, okay, here they are sign of the angle, there it was phi is equal to in terms of sin inverse it was given, correct, answer is after rationalizing, multiplying and dividing by root 2, we get root 2 by 10, sign of the angle between the line and the plane. Question asked in the year 2020. Move on to the next one. Here, plane parallel to the line we have. Plane is parallel to line means normal to the plane is perpendicular to the line. Okay, that's a concept. Line is given like this in the Cartesian form. Plane is given like this in the Cartesian form. Line is parallel to plane means line is perpendicular to the normal to the plane. Direction ratios of the normal to plane is capital ABC. Line is parallel to plane means what happens? Line is perpendicular to normal to the plane. So we have this condition AA plus BB plus CC equals 0. Normal and the line are perpendicular. So AA plus BB plus CC equals 0. Remember this condition for line to be parallel to the plane. There are a few questions based on this. The value of K says that the line lies on the plane. Line is lying on the plane. That means there is a point common. There are infinitely many points common to line in the plane. Line lies in the plane. Of course, line is also parallel to plane here, correct? The line is in the proper form, means coefficient of x, y, z is 1. So denominators are a, b, c, correct? So x minus 4, line is given like this. Line is x minus 4 divided by 1 is equal to y minus 2 divided by 1 is equal to z minus k divided by 2. Denominators are small abc. This is small abc. And the plane is given. Plane is given to us. Equation of the plane is 2x minus 4y plus z is equal to 7. This is ax plus by plus cz is equal to d. If we compare direction ratios of normal to plane, I can write direction ratios of normal to the plane. What are direction ratios of normal to the plane? 2 minus 4 1. Capital A, B, C are direction ratios of normal to the plane. So here line is lying in the plane, means there are common points for line and plane. Then point on the line also lies on the plane. That is also their condition, but I am not going to use that condition. I am just using the condition that AA plus BB plus CC equal to 0. Line is parallel to plane. Line is parallel to plane implies line is parallel to plane implies line is perpendicular to normal to the plane. Line is perpendicular to normal to the plane. So direction ratios of line is here. Direction ratios of normal is here. Apply the condition AA plus BB plus CC equal to 0. Oh, that condition is not required here to get the answer. Of course, you can verify it because my aim is to find the value of k here. Means the point on the line is also on the plane. That condition I should use to get the value of k. Of course, that condition will be satisfied here. See, 1 into 2, correct? 1 into 2, AA plus BB, 1 into 2 plus 1 into minus 4, 1 into minus 4 plus 2 into 1, correct? 2 into 1, correct? That is how much? 2 minus 4 plus 2 equal to 0. Of course, it is true. Line is perpendicular to normal. But another condition I am going to apply here is because the line is lying in the plane, the value of k says that line lies on the plane. Line is lying on the plane means the point on the line is also the point on the plane. What is the point on the line? The point on the line is 4, 2, k, because line passes through the point 4, 2, k. Point on the line is, I am going to use this condition. Point on the line is 4, 2, k, because line passes through the point 4, 2, k, 4, 2, k. This point on the line should lie on the plane. So that line lies on the plane. This should lie on the plane. This should lie on the plane. This should lie on the plane. What is the condition for this point to lie on the plane? This point should lie means it satisfies this equation, correct? In place of x you put 2 into x is 4 minus 4 into y is 2 plus z is k equal to 7, correct? Substitute x is 4, y is 2 and z is k. 2 into 4 minus 4 into 2 plus k equal to 7. Put x as 4, y as 2 and z as k. How much you get? 2 into 4, 8. 8 minus 8, 0. K equal to 7 I get. The value of k is 7. Please make a note. There are two conditions for line to lie in a plane. Point on the line is also a point on the plane and the line is parallel to plane. Both the condition works here whenever a line lies on the plane. Question asked in the year 2018. What is the next one? The line given like this, is parallel to the plane. Here just use the condition AA plus BB plus CC equal to 0. Which line is, the given line is parallel to which plane you have to find out. So verify that the line is perpendicular to normal to the plane. So line is in the standard form, coefficient of x, y, z, 1. So direction ratios of the line has direction ratios 3, 4, 5, correct? The direction ratios of the line are 3, 4 and 5. Denominators will give direction ratios proportional to, correct? Parallel to the given line. So denominator is direction ratios of the given line. The line is in the standard form because coefficient of x, y, z all are 1 here. And first option we verify whether it satisfies AA plus BB plus CC equal to 0, correct? I think directly I can tell third option satisfies. If we take third option, option C is the given 2x plus y minus 2z equal to 0. Verify this into this, 2 into 3, 2 into 3, this into this, plus 4 into 1, correct? 4 into 1, plus 5 into minus 2. If you verify, this is small ABC, this is capital ABC, direction ratios of the normal. I am verifying AA plus BB plus CC, whether it comes to 0, check. 2 into 3, 6, 4 into 1, 4, minus 5 into 2, minus 10, 6, 10 minus 10, 0, satisfies. Option C is the answer. Looking at this, easily can control because all other options, coefficient of x, y, z are positive. Here coefficient of z is negative. So I can take easily option C and verify. So line is parallel to plane means line is perpendicular to normal to the plane. Normal is perpendicular to line. That means AA plus BB plus CC equal to 0. Small ABC are direction ratios of the line. Capital ABC are direction ratios of normal to the plane. Question asked in the year 2014. Move on to the next one. Here, angle between the two planes is defined as angle between the normals drawn at the point of intersection. Formula is same as we had angle between two lines. Here, what matters is the normal to the planes. N1 vector, N2 vector, the normal to the plane, cos inverse in the vector form and Cartesian form. It's almost same as angle between two lines we had. But here, angle between two planes, here it depends upon the normal to the plane. N1 vector is normal to first plane, N2 vector is normal to second plane. And here it is given in terms of Cartesian form. And condition for parallel planes we have A1 by A2 equal to B1 by B2 equal to C1 by C2. And for perpendicular planes we have A1 A2 plus B1 B2 plus C1 C2 equal to 0. Same condition as we had in lines also. There are a few questions based on this. Locus represented by this xy plus yz equal to 0 is what? Question asked in the 2018. So xy plus yz equal to 0 could be written as xy plus yz is equal to 0. From this we can take y common. Y if we take common, x plus z is equal to 0. A into b 0 means either a equal to 0 or b equal to 0. Y equal to 0 or x plus z is equal to 0. Y equal to 0 could be written as, that is, y equal to 0 could be written as 0x plus 1y plus 0z is equal to 0. This is equation 1. Y equal to 0, then as 0x plus 1y plus 0z equal to 0. X plus z equal to 0 could be written as 1 into x plus 0 into y plus 1 into z is equal to 0. Equation 2. 1 into x plus 0 into y plus 1 into z equal to 0. The two planes you can see they are perpendicular to each other because it satisfies a1 a2 plus b1 b2 plus c1 c2 equal to 0. If you find out a1 a2 plus b1 b2 plus c1 c2 is how much? This is a1 b1 c1, a2 b2 c2, 0 into 1, correct? 0 into 1 plus 1 into 0 plus 0 into 1, correct? This is equal to 0 plus 0 plus 0 is equal to 0. A1 A2 plus B1 B2 plus C1 C2 0 means it represents a pair of perpendicular planes. So it represents a pair of perpendicular planes. Option D is the answer. It can't represent line, of course, because it takes the form AX plus BY plus CZ equal to means it represents a plane. It satisfies the condition A1 A2 plus B1 B2 plus C1 C2 equal to 0. 0 into 1 plus 1 into 0 plus 0 into 1. 0 plus 0 plus 0 equal to 0 represents a pair of perpendicular planes. Question asked in the year 2018. Move on to the next one. We have equation xy equal to 0 in 3-dimensional space represents what? Xy equal to 0 implies either x equal to 0 or y equal to 0. Correct? X equal to 0 or y equal to 0. X equal to 0 could be written as 1 into x plus 0 into y plus 0 into z equal to 0. Y equal to 0 means I can write as 0 into x plus 1 into y plus 0 into z equal to 0. Equation 2. X equal to 0 means 1x equal to 0. Y equal to 0 means 1y equal to 0. Here also you can verify a1 a2 plus b1 b2 plus c1 c2 will be 0. a1 a2 plus b1 b2 plus c1 c2 you find out. a1 a2 1 into 0 plus 0 into 1 plus 0 into 0. Correct? 1 into 0, 0. 0 into 1, 0. 0 into 0, 0. Therefore, a1, a2 plus b1, b2 plus c1, c2, 0. That means it represents a pair of perpendicular planes. Pair of perpendicular planes. Pair of planes at right angles. Option C is answer. Pair of planes which are at right angles to each other. Correct? ax plus by plus cz equal to d means it represents a plane. It satisfies this condition. a1 a2 plus b1 b2 plus c1 c2 0 means planes are at right angles. Option C is answer. Question asked in the 2024. Please make a note. Move on to the next one. Foot of the perpendicular and image of a point with respect to the plane. So, if you want to find the foot of the perpendicular from a point to the plane, this is a formula. H comma k comma l is the foot of the perpendicular. It satisfies h minus x1 by a equal to k minus y1 by b equal to l minus z1 by c equal to minus of ax1 plus by1 plus c by a square plus b square plus c square. This is foot of the perpendicular drawn from the point to the plane. Okay, earlier we did foot of the perpendicular drawn from the point to the line. This is to the plane, remember. And same way image, same formula, but here slight modification. Instead of minus, here minus 2 is it. Okay, learn these formulas, quite useful to find the foot of the perpendicular and image of a point with respect to the given plane. We'll work out the problems based on this. Okay, finding the coordinates of the foot of the perpendicular drawn from origin to the plane. Of course, here I can use another method here, that is LD, MD, ND. Whenever they mention foot of the perpendicular drawn from origin to the plane, we can use directly LD, MD, ND because we had in the normal form. This is LD, MD, ND. D is the distance of the plane from the origin, and L, M, N are direction cosines of the normal vector. Okay, so 5y plus 8 equal to 0. No, that plane is given to us. The plane is given to us as 5y plus 8 equal to 0. 5y plus 8 equal to 0. We can write it as 0x plus 5y plus 0z equal to minus 8 or plus 8 equal to 0. Okay, we can write like this: 0x plus 5y plus 0z plus 8 equal to 0, or you can write it as 0x minus 5y minus 0z is equal to plus 8. Minus 8 equal to 0 equal to plus 8. You can compare this with Lx plus My plus Nz. We'll divide by the magnitude of this. Magnitude of this normal vector is going to be equal to 5. Okay, magnitude of this is going to be equal to 5. So divide by 5 magnitude of this normal vector. Normal vector is 0i minus 5j minus 0k. So if you divide by 5, I'm going to get 0x minus y minus 0z is equal to 8 by 5. Okay. Now compare with Lx plus My plus Nz equal to d. Comparing with Lx plus My plus Lx plus My plus Nz is equal to d. So L is equal to 0, M is equal to minus 1 and N is equal to 0. and D is equal to 8 by 5. Distance can't be negative, so I multiply by minus 1, and using this we'll get the foot of the perpendicular. This is the foot of the perpendicular. LD, MD, and D. LD 0 into 8 by 5, 0. Correct? Minus 1 into 8 by 5, minus 8 by 5. And ND 0. Correct? 0 minus 8 by 5, 0. That's the answer. Foot of the perpendicular. Just use this formula. This gives the foot of the perpendicular drawn from origin to the plane. Whenever they mention the word origin, then only you can use this. Foot of the perpendicular drawn from origin to the plane. Lx plus my plus nz equal to d. Quite simple one. Question asked in the year 2016. Move on to the next one. This is question asked in the year 2022. Coordinates of the foot of the perpendicular drawn from origin to the plane. So whenever they use the word origin to the plane, foot to the perpendicular, we can avoid that formula. H minus x1 by a equal to k minus y1 by b equal to minus of ax1 plus by1 plus c by a square plus b square plus c square. That formula is not required. If you want, you can apply, you'll get the answer. But I'll use Lx plus my plus nz equal to d. Given plane is 2x minus 3y plus 4z equal to 29. Okay, normal vector to the plane is, normal vector is 2i minus 3j plus 4k. You divide by magnitude of this. What is the magnitude of this vector? Magnitude of this normal vector is going to be root of 2 square 4 minus 3 square 9, 4 square 16, which is root 29. So you divide by root 29. This equation becomes what? 2 by root 29 into x minus 3 by root 29 into y plus 4 by root 29 into z. When you divide by root 29, I am going to get root 29. Compare this with Lx plus my plus nz is equal to d. Okay. So what we get? L is equal to 2 by root 29. L is 2 by root 29. M is equal to minus 3 by root 29. And n is equal to 4 by root 29. Okay. So foot of the perpendicular is LD, MD, MD. LD, MD, ND. And D is here. D is this, root 29. Correct. So multiply LD. That is 2 by root 29 into root 29. That is 2. 3 minus 3 by root 29 into root 29. That is 3 minus 3. 4 by root 29 into root 29, that is 4. 2 comma minus 3 comma 4. Option C is the answer. Foot of the perpendicular. Please make a note. Question asked in the year 2022. 2 comma minus 3 comma 4 is the answer. Option C. Move on to the next one. Question number 3 we have on this. Foot of the perpendicular drawn from 1 comma 3 comma 4 to this plane. Now it's not drawn from origin. So I won't be using that shortcut method. LD, MD, and I won't use. I'll use the regular formula. That is h minus x1 by a. H minus x1 divided by a is equal to k minus y1 divided by b is equal to L minus Z1 divided by C is equal to minus of AX1 plus BY1 plus C. AX1 plus BY1 plus CZ1 plus D divided by A square plus B square plus C square. This is the formula. AX1 plus BY1 plus CZ1 plus D by A square plus B square plus C square. Okay, the point is this, x1, y1, z1. x1, y1, z1. The plane is this, A is here, B is here, C is here, D is here. Ax plus by plus cz plus d. Substitute. You have to find hkl. So this is h minus x1. x1 is 1 divided by A is 2 is equal to k minus y1. y1 is 3. y1 is 3 divided by b. b is minus 1. L minus z1 is 4 divided by c is 1. Correct? A, B, C. 2, minus 1, 1. Correct? A, B, C is equal to minus of AX1. AX1, 2 into 1, 2. Correct? A into X1. B into Y1, minus 1 into 3, minus 3. C into Z1, 1 into 4, 4. Plus D divided by A square plus B square plus C square, 2 square 4, minus 1 square 1, 1 square 1, correct? Like this I am getting. H minus X1, X1 is 1, Y1 is 3, Z1 is 4, A, B, C, 2 minus 1, 1, A into X1, 2 into 1, 2, B, Y1, minus 1 into 3, minus 3, 1 into 4, 4, plus 3, divided by A square plus B square plus C square, 4 plus 1 plus 1. So what I am getting is H minus 1 divided by 2, K minus 3 divided by minus 1, L minus 4 divided by 1. Here minus 3 plus 3 will cancel. 2 plus 4, 6. 6 by 6, 1. Minus 1. Equate the first and last. Correct? This simplifies to 6 by 6, 1. 1 into minus, minus 1. So h minus 1 by 2 equal to 1. H minus 1 by 2 equal to minus 1. I am getting. H minus 1 divided by 2 is equal to minus 1. So what you get is h minus 1 is equal to minus 2, which gives h is equal to minus 2 plus 1, which is minus 1. H minus 1 by 2 equal to minus 1. Correct? H minus 1 equal to minus 2. H is minus 2 plus 1, which is minus 1. K minus 3 by minus 1 is equal to minus 1. K minus 3 is equal to minus into minus plus 1. K is equal to 1 plus 3, which is 4. L minus 4 by 1 is equal to minus 1. So L minus 4 is equal to minus 1. So L is equal to, what we get is minus 1 plus 4, which is 3. So minus 1, 4, 3, which is option B. Correct? Foot of the perpendicular. Minus 1, 4, 3. Option B is the answer. Please make a note of this. Question asked in the year 2019. Move on to the next one. Here also we have one more question on finding the foot of the perpendicular drawn from origin to the plane. So we can use the shortcut here, LD, MD, ND and get the answer. Correct? So the plane is given like this, 2x minus 3y plus 4z equal to 29. Plane is given to be 2x minus 3y plus 4z is equal to 29. Normal to the plane is 2i minus 3j plus 4k. If you find out its magnitude of this vector, this we call it as vector n. Normal vector, that is magnitude of this is going to be root of 2 square 4 minus 3 square 9, 4 square 16, which is root 29, divide by root 29, the plane becomes 2 by root 29 into x minus 3 by root 29 into y plus 4 by root 29 into z, correct? 29 by root 29 is root 29. Compare with Lx plus My plus Nz is equal to D. So L is 2 by root 29. M is minus 3 by root 29. N is 4 by root 29. Distance is also root 29. Coordinates of the foot of the perpendicular is LD, MD, ND. Foot of the perpendicular is LD, MD, ND. time saving result. You can do the regular method also. You can find out the equation of normal, and normal is drawn, perpendicular is drawn from the origin to the plane. No, we can find out the equation of the normal and also solve that normal with the plane. We'll get the foot of the perpendicular. That method also we can do. So multiply this 2 by root 29 into root 29, that becomes 2. Minus 3 by root 29 into root 29 becomes minus 3. 4 by root 29 into root 29 is 4. 2 comma minus 3 comma 4. I think this is the same question asked earlier. 2 comma minus 3 comma 4. Same question. 2015 and 22. 2 times. Same question is asked. If you want, I can do the traditional method also. That is, you can write the equation of normal to the plane and solve that. I'll do that also. So, equation of normal is what? Equation of normal from the origin to plane. Equation of normal from the origin is what? It passes through origin, right? Normal is passing through the origin because it is drawn from the origin. X minus 0 by, y minus 0 by, z minus 0 by. What are direction ratios of the normal? Because plane is given to us as this. The coefficient of x by z will be the direction ratios of the normal, which is 2 minus 3, 4. Correct? 2 minus 3, 4. Direction ratios of normal is 2 minus 3, 4. Take this as a lambda. So what do you get? X is equal to 2 lambda, y is equal to minus 3 lambda, and z is equal to 4 lambda. Correct? This you substitute. Put this in the equation of plane. Put this in the equation of plane. What is the equation of plane? 2x minus 3y plus 4z equal 29. 2x minus 3y plus 4z is equal to 29. Correct? What do you get? 2 into x is 2 lambda minus 3 into y is minus 3 lambda plus 4 into z is 4 lambda is equal to 29. Correct? So what you get is 4 lambda plus 9 lambda plus 16 lambda is equal to 29. So this gives 29 lambda is equal to 29. That means lambda is equal to 1. Therefore, substitute this value of lambda equal to 1. We'll get the foot of the perpendicular, which is, put lambda equal to 1 here. This is the foot of the perpendicular actually. Point common to the plane and this is the foot of the perpendicular actually. Correct? Equation of, I am solving the equation of normal and the equation of the plane. Equation of normal I wrote, and that equation of normal I am going to substitute in the equation of the plane. Point of intersection of normal from the origin to the plane. Point of intersection of the plane and the normal will give the foot of the perpendicular. Therefore, put lambda equal to 1 in this. We'll get the foot of the perpendicular. This method also we can do. Foot of the perpendicular. Put lambda equal to 1 in this. 2 into 1, 2. Minus 3 into 1, minus 3. 4 into 1, 4. That's the answer. 2 comma minus 3 comma 4. Hope it's clear. Move on to the next one. We have distance of a point to the plane. This is vector form and this is in the Cartesian form. Mod of ax1 plus by1 plus cz1 minus d by root of a square plus b square plus c square. Plane is given ax plus by plus cz equal to d, and the point is given x1, y1, z1. In the Cartesian form also, in vector form also, we have a dot n minus d by magnitude of vector n. And in the, if it is unit normal vector, then it is a dot n cap minus d. That's the distance. Whenever they give the equation of a plane and the point, better convert it to Cartesian form and do it. That's the easiest way, so that you can remember easily this formula. That also you can remember, not a big deal. A dot n minus d, magnitude of that by mod of vector n. So better to do it in the Cartesian form. One such question is asked here. Distance of the point whose position vector is given and the plane is given. So point is 2i plus j minus k. That means the point is 2 comma 1 comma minus 1. Point is 2 comma 1 comma minus 1. You are asking to find the distance, the perpendicular distance from the point to the plane. The distance between the point and the plane, the perpendicular distance formula between the point and the plane, also called length of the perpendicular from the point to the plane. Point I wrote in the coordinates form, 2 comma 1 comma minus 1. Plane you convert it to Cartesian form and write. Vector r, if you take xi plus yj plus zk and take the dot product, equation of plane becomes, the plane is, I'm getting, the plane is x minus 2y plus 4z equal to 4, or you can write minus 4 equal to 0. The point is x1, y1, z1. And the plane is ax plus by plus cz minus d equal to 0. Distance between the point and the plane is mod of a into x1 plus b into y1 plus c into z1 minus d divided by root of a square plus b square plus c square. Finding the length of the perpendicular from the point to the plane. This is mod of a into x1, multiply, a is 1 here, 1 into 2, 2, plus b into y1, minus 2 into 1, minus 2, plus c into z1, 4 into minus 1, minus 4, d is 4, correct, divided by root of a square plus b square plus c square, 1 square 1, plus minus 2 square 4, plus 4 square 16, plus 2 minus 2 will cancel, minus 4 minus 8, mod of minus 8 is 8 divided by root of 21, 8 by root 21 is answer. Question asked in there 2022. Please make a note. Move on to the next one. Here, distance between the two parallel planes, two planes in this form, parallel planes, distance between them is mod of d1 minus d2 by root of a square plus b square plus c square. Learn this as a formula. We have one such question on this. Find the distance between the two parallel planes. So, identify that two planes are parallel. First plane, keep as it is. Second plane, you can divide by 2 and write. First plane is 2x plus 3y plus 4z is equal to 4. Second plane, I'll divide by 2 and write. Divide by 2. So what do you get? 2x plus 3y plus 4z is equal to 6. Divide by 2 and write. Distance between the two parallel planes is mod of d1 minus d2 by root of a square plus b square plus c square. This is d1 d2 or d1 4 minus 6 mod of 4 minus 6 divided root of a square plus b square plus c square. 2 square 4, 3 square 9 and 4 square 16. Mod of minus 2 is 2. This is root 29. 2 by root 29 is answer. Option C. This compare with this form. Ax plus by plus cz equal to d1, ax plus by plus cz equal to d2. Identify d1 and d2. Apply this formula. Mod of d1 minus d2 by root of a square plus b square plus c square. This is d1 and d2. This is your d1. And this is your d2. Mod of d1 minus d2 by root of a square plus b square plus c square. Distance between the two parallel planes. Question asked in the year 2024. Move on to the next concept, one more last one here. Point of intersection of the line and the plane is asked. So, point of intersection of the line and the plane you have to find out. POI. Point of intersection, we can call it in short POI. POI. POI is point of intersection of the line and the plane. So, line is given like this. X plus 1 is equal to y plus 3 by 3. Take any point on the line as lambda. General point will write down of this point by 2. Correct? Let this be equal to lambda. We are solving the equation of line with the equation of plane. From this, what we get? X is equal to lambda minus 1. X is lambda minus 1. Y plus 3 is 3 lambda. So, y is 3 lambda minus 3. Z is how much? Minus Z I'll get. Minus Z is 2 lambda minus 2, or Z is equal to 2 minus 2 lambda. Z is correct because they given minus Z plus 2. Minus Z plus 2 will be 2 lambda. Minus Z is 2 lambda minus 2. Cross multiply, rearrange. So Z will be 2 minus 2 lambda. Substitute this in the equation of plane. Put this in equation of plane. Put this in equation of plane. 3x plus 4y plus 5z is equal to 10. What do you get? 3 into x is lambda minus 1 plus 4 into y is 3 lambda minus 3 plus 5 into z is 2 minus 2 lambda is equal to 10. Substitute for x, y and z. 2 minus 2 lambda. So what you get is 3 lambda minus 3, 12 lambda minus 12, 10 minus 10 lambda is equal to 10. Correct? X is lambda minus 1, y is 3 lambda minus 3, minus z is 2 lambda minus 2, z is 2 minus 2 lambda. Substitute x, y you substitute and z you substitute 2 minus 2 lambda. 3 lambda minus 3, 4 3 is 12 lambda minus 12, 10 minus 10 lambda, correct? So what you get is plus 10 is going to cancel. 3 lambda plus 12 lambda, 15 lambda. 15 lambda minus 10 lambda, that is 5 lambda. 5 lambda I am getting, correct? No? 3 plus 12, 15. 15 minus 10, which is 5 lambda. 5 lambda. Your minus 12 minus 3 is minus 15 plus 10 is going to cancel. Minus 15 equal to 0. This gives lambda equal to 3. Put this lambda equal to 3, you'll get the point of intersection of the line and the plane. So put lambda equal to 3 in this. Therefore, the point of intersection, POI, right? Point of intersection is x is lambda minus 1, y is 3 lambda minus 3, and z is 2 minus 2 lambda. Put lambda equal to 3 and write. Put this value of lambda equal to 3. 3 minus 1, 2. Put lambda equal to the 3 3s are 9. 9 minus 3 is 6. Lambda is 3. Put 2 3s are 6. 2 minus 6, which is minus 4. Correct? 3 minus 1, 2. 3 into 3, 9. 9 minus 3 is 6. 2 3s are 6. 2 minus 6, which is minus 4. 2 comma 6 comma minus 4, which is option D. Question asked in the year 2023. Point of intersection of the line and the plane. 2, 6 minus 4. Correct, no? Option D is answer. I think with this we conclude. All the questions have been completed of 3-dimensional geometry. Total we had 46 questions from 2014 to 2025. All the PYQs covered in this. Many more videos will be uploaded in the coming days. Please subscribe to my channel and forward to your friends. Okay, even vector algebra, matrices, determinants, KCET PYQ series will be continued, and also JEE mains also will be uploaded. Synopsis part for KCET and JEE will be done separately along with examples. Please subscribe to my channel and forward to your friends. With this I conclude. Thank you.